SAP integration nightmares during ECC to S/4HANA migration.
Most ECC to S/4HANA migrations do not fail inside S/4HANA. They fail outside it. Interfaces run green. Monitoring looks clean. Yet banks reject files, BW totals don't match, tax engines miscalculate, and business users lose trust. This video exists to explain why.
Why integration failures are the most dangerous migration risks.
Integration failures are the hardest to diagnose because they rarely dump, rarely alert, and often surface weeks after go live. By the time they are noticed, the damage has already propagated to downstream systems. This is why SAP integration consultants spend most of go live in war rooms.
How this video is structured.
This is not a tutorial. This is a diagnostic guide built from real migration programs. 1. Each scenario starts with what the business experiences outside S/4HANA. 2. We explain why the issue is confusing and why monitoring stays green. 3. We show why the failure happens only during ECC to S/4HANA migration. 4. Ownership is clearly identified: who leads, who supports, and who cannot fix it alone. 5. We separate correct fixes from common wrong fixes that create long-term instability.
What we are covering in this video.
This video focuses exclusively on SAP integration migration failures. 1. PI or PO, CPI, and middleware behavior changes during migration. 2. Downstream system failures such as BW, BPC, banking, and tax engines. 3. Legacy IDoc assumptions breaking in an API-driven S/4HANA world. 4. Timing, performance, and parallel execution side effects. 5. Post-go-live issues that appear only under real business load.
29 real migration scenarios, no theory.
This video covers 29 migration-exclusive scenarios faced by SAP integration consultants. These are not generic interface problems. Every scenario exists because of the shift from ECC to S/4HANA, the data model, the execution model, or the integration strategy.
Categories covered in this video.
1. Legacy to modern integration transformation, 5 scenarios. 2. Core data model and semantic breaks, 3 scenarios. 3. Timing, parallelism, and performance shifts, 3 scenarios. 4. BW, BPC, and analytics integration failures, 3 scenarios. 5. Banking, tax, and external engine failures, 3 scenarios. 6. Security and connectivity failures, 3 scenarios. 7. Testing and cutover blind spots, 3 scenarios. 8. Post-go-live ghost issues, 3 scenarios. 9. Ownership and governance failures, 3 scenarios.
Category 1. Legacy to modern integration transformation.
The most underestimated change in S/4HANA migration is not performance or data volume. It is modernization. ECC relied on IDocs and table-based logic. S/4HANA is built around business objects, APIs, and event-driven behavior. When legacy integration patterns are forced into S/4HANA, failures become inevitable.
Scenarios covered in Category 1.
1. Legacy vendor IDoc works in ECC but fails silently in S/4HANA. 2. Forcing ECC IDocs instead of using S/4HANA business partner APIs. 3. CPI API payload is structurally correct but business logic fails. 4. Partial modernization creates IDoc and API data inconsistency. 5. Event-based integration breaks batch-oriented legacy assumptions.
Scenario 1. Legacy vendor IDoc works in ECC but fails silently in S/4HANA.
After migration, inbound vendor master data continues to arrive from an external system using the classic CREMA's IDoc. The IDoc posts successfully with green status. However, finance users later discover that vendor postings fail or certain vendors behave inconsistently across company codes. The interface team insists the IDoc is posting fine.
What the business sees and why this is confusing.
From the outside, everything appears normal. This is why the issue escalates late. 1. IDoc status is green and no technical errors are reported. 2. Vendor records exist in S/4HANA and appear complete at first glance. 3. Posting failures occur only in specific processes such as MIRO or automatic payments. 4. Different teams see different symptoms, making the issue appear random.
Why this happens only in an S/4HANA migration.
This failure did not exist in ECC because the underlying business object has changed. 1. ECC vendor IDocs wrote directly to vendor tables and were considered complete once posted. 2. S/4HANA replaces vendors with the business partner object, which has multiple mandatory roles and layers. 3. CREMA's IDocs do not automatically populate all required business partner roles and attributes. 4. The system accepts the IDoc structurally, but business logic later fails due to incomplete BP semantics.
Ownership identification and parts to fix.
This issue is not owned by finance alone. Integration leads the diagnosis, but resolution requires coordination across roles. 1. Integration consultant identifies that the legacy IDoc contract no longer matches S/4HANA business object expectations. 2. FICO consultant validates which BP roles and attributes are required for financial postings. 3. ABAP team confirms how IDoc processing maps to business partner creation logic. 4. Data migration team reviews BP completeness rules and migration alignment. 5. Project leadership decides whether to continue legacy IDocs or move to API-based integration.
How this is actually fixed, the right way by a role.
1. Integration team evaluates replacing CREMAs with the business partner OData API for vendor creation. 2. FICO team defines mandatory BP roles and validates financial impact of incomplete master data. 3. ABAP team ensures API-based creation enforces full BP semantics instead of table-level rights. 4. Leadership approves modernization instead of forcing legacy ECC behavior into S/4HANA.
What not to do, common wrong fixes.
1. Reposting vendor master data repeatedly to fix missing behavior. 2. Granting broad authorizations to bypass posting errors. 3. Custom enhancing IDoc processing to patch missing BP roles. 4. Ignoring the issue because the IDoc status is green.
Follow-up 1. Why does the IDoc post successfully if the data is incomplete?
Answer: because the IDoc framework validates structure and syntax, not full business semantics. S/4HANA allows technically valid objects to be created, but enforces completeness only when the data is used in downstream financial processes.
Follow-up 2. Can we just extend the IDoc instead of moving to APIs?
Answer: you can, but it creates long-term technical debt. Extending IDocs to mimic business partner behavior often results in fragile logic that breaks with upgrades. SAP's strategic direction is API-based integration for a reason.
Follow-up 3. Curveball. Why do these issues often surface only after go-live?
Answer: because testing usually validates that the interface runs, not that the business object behaves correctly across all processes. Production exposes edge cases like payment runs, tax posting, and cross-company usage that testing rarely covers.
Exclusive pro tip.
If an integration team says the IDoc is green, ask a second question immediately: does the business object behave correctly everywhere? In S/4HANA, green status does not mean business readiness.
Scenario 2. Forcing ECC IDocs instead of using S/4HANA Business Partner APIs.
After migration, the integration team continues to use classic ECC IDocs like CREMAs and DEBMAs to create or update vendors and customers. Technically, the IDocs are processed, and monitoring shows success. However, downstream finance postings fail, credit checks behave inconsistently, and business partner data appears incomplete or fragmented across roles.
Scenario analysis and root cause.
This issue is confusing because the integration layer appears stable, yet business processes fail unpredictably. 1. ECC IDocs were designed around table-based customer and vendor models, not business partner objects. 2. S/4HANA enforces business partner as a single semantic object with roles, relationships, and lifecycle rules. 3. Classic IDocs may populate some BP tables but do not guarantee full role consistency required by S/4 processes. 4. Key insight: the failure is not technical transmission. It is semantic mismatch between legacy IDocs and modern business objects.
Why this happens only during ECC to S/4HANA migration.
1. ECC allowed customer and vendor objects to exist independently with loose validation. 2. S/4HANA consolidates these into business partner with mandatory role synchronization. 3. IDocs that worked in ECC were never designed to enforce BP completeness. 4. Migration exposes this gap because the underlying business object model has fundamentally changed.
Ownership, integration-led, architectural decision.
This is not a coding bug or a configuration oversight. It is an architectural decision failure. 1. Integration consultant owns the decision to modernize interfaces and stop forcing legacy IDocs. 2. FICO consultant defines which BP roles and attributes are mandatory for finance processes. 3. ABAP team supports API enablement and error handling, not IDoc extensions. 4. Data team validates BP completeness across all required roles. 5. Leadership approves interface redesign instead of temporary backward compatibility hacks.
How this is actually fixed, the right way by a role.
1. Integration team replaces legacy cremas or DEBMAs with S4 HANA Business Partner APIs via CPI. 2. FICO team defines mandatory BP roles and validates business process dependencies. 3. ABAP team supports API error handling and monitoring, not table-level fixes. 4. Data team ensures all BP roles are consistently populated across inbound messages. 5. Leadership enforces a clean cut from legacy patterns, instead of allowing hybrid shortcuts.
What not to do, common wrong fixes.
1. Extending legacy IDocs endlessly to mimic business partner behavior. 2. Manually fixing BP roles after IDoc processing. 3. Ignoring SAP recommendations and forcing ECC patterns into S4. 4. Assuming successful IDoc status means business correctness.
Follow-up 1. Why do IDocs appear successful but still break business processes?
Answer: IDocs validate structural correctness, not semantic completeness. In S4 HANA, business processes depend on BP roles and relationships that IDocs were never designed to enforce. The IDoc can post successfully while still leaving the BP in an unusable state.
Follow-up 2. Can we keep IDocs temporarily and switch later?
Answer: this creates hybrid landscapes where some processes rely on APIs and others on IDocs. These hybrids are extremely hard to govern and almost always result in data inconsistencies. Most projects that try this end up rewriting interfaces twice.
Follow-up 3. Curveball. Why does SAP strongly push APIs even if IDocs still exist?
Answer: because APIs enforce business object integrity, not just data transfer. SAP's roadmap is centered on object consistency, eventing, and lifecycle management. IDocs are backward compatibility tools, not future-proof integration mechanisms.
Exclusive pro tip.
If an interface design decision is made before understanding business partner semantics, the migration has already failed, even if go-live succeeds.
Scenario 3. CPI API payload is structurally correct, but business logic fails.
After migration, legacy IDocs are replaced with S4 HANA APIs exposed via SAP CPI. Payloads are well-formed, messages are processed successfully, and CPI monitoring shows green status. However, finance postings fail, credit checks behave unpredictably, and downstream systems report incomplete or inconsistent business partner data.
Scenario analysis and root cause.
This failure is especially dangerous because technically everything appears correct at the integration layer. 1. CPI validates message structure and API contract compliance, not end-to-end business semantics. 2. S4 HANA APIs enforce deep business rules that depend on role sequencing, dependencies, and lifecycle state. 3. A payload can be syntactically correct but still violate business expectations such as missing BP roles or relationships. 4. Key insight: API success does not equal business success. Logic validation happens inside S4, not in CPI.
Why this happens only during ECC to S4 HANA migration.
1. ECC interfaces relied on table-level persistence with minimal semantic validation. 2. S4 HANA APIs are business object-driven and enforce lifecycle and dependency rules. 3. Migration exposes payload assumptions that were never validated in ECC. 4. The shift from data-centric to object-centric integration is unique to S4 transformations.
Ownership, integration-led, multi-team fix.
This issue cannot be solved by the integration team alone, even though it originates in CPI. 1. Integration consultant analyzes payload sequencing and ensures API contracts align with business flow. 2. FICO consultant defines mandatory BP roles, credit logic, and posting dependencies. 3. ABAP team assists in interpreting API error handling and backend validation messages. 4. Data team validates completeness and consistency of business partner records. 5. Leadership prevents premature sign-off based solely on CPI monitoring success.
How this is actually fixed, the right way by a role.
1. Integration team validates not just payload structure, but also the business sequence of API calls. 2. FICO team confirms which roles and attributes must exist before downstream processes execute. 3. ABAP team decodes backend validation logs instead of masking errors at CPI level. 4. Data team confirms that API-created objects meet all lifecycle and dependency requirements. 5. Leadership enforces end-to-end business validation instead of interface-only sign-off.
What not to do, common wrong fixes.
1. Adding CPI mapping logic to suppress backend errors. 2. Hard-coding default values to force API success. 3. Retrying messages without fixing underlying business logic. 4. Assuming API success guarantees downstream usability.
Follow-up 1. Why doesn't CPI catch these business logic failures earlier?
Answer: CPI validates message format and routing, not business object integrity. The API contract ensures structural compliance, but semantic validation occurs only when S4 processes the object. This separation is by design and is often misunderstood during migration.
Follow-up 2. Can we add custom validation in CPI to prevent this?
Answer: you can add basic checks, but replicating S4 business logic in CPI is dangerous and unsustainable. Doing so creates duplicate logic that quickly becomes inconsistent. The correct approach is to align payload design with S4 expectations, not copy them.
Follow-up 3. Curveball. Why do these issues often surface only under production load?
Answer: production introduces parallel processing, timing differences, and full role coverage that are rarely simulated in test environments. These factors expose sequencing and dependency issues that remain invisible during controlled testing.
Exclusive pro tip.
Never certify an interface based on CPI success alone. Certification must include downstream business execution using production-like data and roles.
Scenario 4. Partial modernization IDoc plus API mix creates data inconsistency.
During migration, the project decides to modernize only selected interfaces. Some processes continue using legacy IDocs, while others move to S4 HANA APIs via CPI. Initially, everything appears to work. Over time, finance notices duplicate business partners, mismatched master data attributes, and inconsistent reporting between systems.
Scenario analysis and root cause.
This failure is caused by architectural inconsistency rather than technical defects. 1. Legacy IDocs and modern APIs follow different data ownership and lifecycle rules. 2. IDocs often bypass strict validation, while APIs enforce business object consistency. 3. Running both simultaneously allows the same business entity to be created or updated through incompatible logic paths. 4. Key insight: mixing integration paradigms breaks the single source of truth principle.
Why this happens only during ECC to S4 HANA migration.
1. ECC landscapes relied almost entirely on IDoc-based integration. 2. S4 HANA introduces APIs as the strategic integration model, not an optional enhancement. 3. Migration phases often allow temporary coexistence, which becomes permanent by accident. 4. This hybrid state exists only during transformation programs, not steady-state operations.
Ownership, not an integration-only fix.
This issue cannot be solved by adjusting mappings or retrying messages. 1. Integration consultant identifies overlapping interface responsibilities and conflicting data flows. 2. FICO consultant defines authoritative source for finance-relevant master data. 3. Data team detects duplicates and semantic inconsistencies across creation channels. 4. ABAP team assists in identifying legacy enhancements still triggered by IDocs. 5. Leadership enforces a single integration strategy and decommissions partial solutions.
How this is actually fixed, the right way by a role.
1. Integration team designs a clear cutover plan that retires legacy IDocs once APIs are live. 2. FICO team confirms which system owns finance-critical attributes such as reconciliation accounts. 3. Data team performs deduplication and consistency checks before allowing parallel flows. 4. ABAP team disables legacy IDoc-triggered enhancements that conflict with APIs. 5. Leadership blocks go-live approval until mixed-mode risks are eliminated.
What not to do, common wrong fixes.
1. Allowing both IDoc and API creation paths for the same object indefinitely. 2. Assuming reconciliation reports will catch inconsistencies later. 3. Treating duplication as a data cleansing problem instead of an architecture flaw. 4. Postponing interface retirement decisions until after go-live.
Follow-up 1. Why does this issue often appear gradually rather than immediately?
Answer: because inconsistencies accumulate over time as different systems update the same objects differently. Early transactions may appear correct, but reporting and reconciliation expose drift as volume increases. This delayed visibility makes the issue harder to trace.
Follow-up 2. Can governance alone prevent this without technical changes?
Answer: no. Governance helps define rules, but without technical enforcement, legacy paths remain active. True prevention requires disabling or redesigning interfaces, not just documenting intended behavior.
Follow-up 3. Curveball. Why do teams knowingly allow partial modernization?
Answer: because full replacement feels risky and time-consuming. Teams underestimate the long-term cost of coexistence and overestimate their ability to control it manually. This trade-off almost always backfires post-go-live.
Exclusive pro tip.
In S4 HANA programs, partial modernization is more dangerous than no modernization. Either commit fully to APIs or accept the cost of legacy systems. Mixing both guarantees data chaos.
Scenario 5. Event-based integration assumptions break batch-oriented legacy logic.
After migration, the integration landscape is redesigned to use event-driven APIs and near-real-time messaging. However, downstream systems that were built around ECC batch cycles suddenly receive partial or premature data. Finance reports show missing postings, duplicate updates, or timing mismatches, even though no interface technically fails.
Scenario analysis and root cause.
This failure is rooted in a mismatch between timing assumptions, not data structure. 1. ECC integrations were predominantly batch-driven and relied on end-of-day completeness. 2. S4 HANA APIs and events trigger on business actions, not accounting finalization. 3. Downstream systems process data immediately, assuming it is final and complete. 4. Key insight: event-driven does not mean business complete.
Why this happens only during ECC to S4 HANA migration.
1. ECC landscapes evolved with implicit batch synchronization across systems. 2. S4 HANA promotes real-time integration without enforcing business process alignment. 3. Migration introduces mixed assumptions between legacy batch logic and modern events. 4. This timing conflict does not exist in pure ECC or pure S4 landscapes.
Ownership, integration-led, architectural decision.
This is not a mapping or retry issue. It is a design decision failure. 1. Integration consultant redefines when data should be omitted versus when it is finalized. 2. FICO consultant clarifies accounting completion points versus operational events. 3. ABAP team identifies legacy batch dependencies embedded in user exits or reports. 4. Data team verifies downstream systems receive complete data sets, not interim states. 5. Leadership approves timing trade-offs and enforces architectural consistency.
How this is actually fixed, the right way by a role.
1. Integration team redesigns interfaces to trigger on business completion events, not raw transactions. 2. FICO team defines clear accounting finalization markers used by integration logic. 3. ABAP team adjusts enhancement points to delay outbound triggers until postings are complete. 4. Data team validates downstream reconciliation using complete business cycles. 5. Leadership prevents go-live with mixed timing semantics across systems.
What not to do, common wrong fixes.
1. Adding artificial delays without understanding business completion. 2. retrying messages assuming data loss instead of timing mismatch. 3. Blaming downstream systems for processing data too quickly. 4. Forcing batch schedules on event-driven architectures blindly.
Follow-up 1. Why do interfaces appear successful but business data is wrong?
Answer: because the interface technically delivers data correctly, just at the wrong time. Downstream systems process information before all dependent postings are complete. This creates logical inconsistency rather than technical failure.
Follow-up 2. Can monitoring tools detect this issue early?
Answer: standard monitoring focuses on message success, not business completeness. Without reconciliation checkpoints, tools will report green while business users see red. Detecting this requires end-to-end process validation.
Follow-up 3. Curveball. Why do teams underestimate this risk during design?
Answer: because real-time sounds superior by default. Teams assume faster data is better data. In reality, finance processes value completeness over speed, and ignoring that principle leads to subtle but severe failures.
Exclusive pro tip.
In finance integration, the most dangerous data is correct data sent too early. Always design integration around business finality, not technical events.
Category 1 wrap-up. When integration is treated as a technical detail.
Legacy to modern integration failures prove that ECC to S/4HANA migration is not just about moving data. It is about replacing assumptions. Projects fail when teams treat integration as plumbing instead of architecture.
Transition from technology shift to data meaning.
Once interfaces are technically connected, a deeper problem emerges. Even when data flows successfully, its meaning may no longer be the same. This is where silent financial corruption begins.
Category 2. Core data model and semantic breaks.
S/4HANA introduces fundamental changes to how financial data is stored, related, and interpreted. Interfaces that worked for decades in ECC can return technically correct data that is semantically wrong. These failures are dangerous because they rarely trigger technical errors.
Scenarios covered in Category 2.
1. Interface reads BSEG and returns wrong or duplicated data, ownership, integration-led multi-team fix. 2. Field length extensions break flat file interfaces, ownership, integration-led data plus ABAP support. 3. Header item semantic changes break mapping logic, ownership, integration-led multi-team fix.
Scenario 1. Interface reads BSEG and returns wrong or duplicated data.
After migration to S/4HANA, downstream systems like BW, tax engines, or reconciliation tools continue to read accounting line items using BSEG-based logic. Technically, the interface runs without errors. However, business users start reporting duplicated values, inflated totals, or unexplained mismatches when compared with S/4HANA reports.
Scenario analysis and root cause.
This issue is confusing because nothing appears broken at a technical level. 1. In ECC, BSEG was the single authoritative source for FI line items. 2. In S/4HANA, financial line items are stored in a CDOCA, with BSEG exposed only via compatibility views. 3. Interfaces reading BSEG now unknowingly consume derived or duplicated records. 4. Key insight: the interface is reading a compatibility layer, not the real data model.
Why this is a migration-exclusive failure.
1. In ECC, BSEG was physically stored and consistent by design. 2. S/4HANA replaces physical tables with compatibility views for backward support. 3. Migration keeps old access paths alive without forcing redesign. 4. This creates silent semantic errors that never existed in ECC.
Ownership, integration-led multi-team fix.
This issue cannot be fixed by finance or integration alone. 1. Integration consultant identifies legacy BSEG dependency in outbound interfaces. 2. ABAP team refactors data access logic to use ACDOCA or released CDS views. 3. FICO consultant confirms which financial totals are business relevant and valid. 4. Data team validates reconciliation results across old and new data sources. 5. Project leadership enforces retirement of legacy access patterns.
How this is actually fixed. The right way by a role.
1. Integration team redesigns interfaces to consume ACDOC-based views instead of BSEG. 2. ABAP team replaces direct table reads with released CDS or APIs. 3. FICO team defines reconciliation rules based on S/4HANA semantics, not ECC expectations. 4. Data team validates historical and current data consistency using new models. 5. Leadership ensures no downstream system continues using compatibility views long-term.
What not to do, common wrong fixes.
1. Manually adjusting totals in downstream systems. 2. Adding filters to BSEG reads to hide duplicates. 3. Reloading data without changing the access logic. 4. Blaming S/4HANA for incorrect numbers without redesigning the interface.
Follow-up 1. Why does SAP keep BSEG if it causes problems?
Answer: SAP keeps BSEG as a compatibility layer to allow older custom code to run temporarily. It is not meant to be a permanent integration source. Using it long-term introduces semantic risk that SAP expects customers to eliminate during migration.
Follow-up 2. How do you prove that duplication comes from compatibility views?
Answer: by comparing record counts and totals between BSEG-based queries and direct ACDOC queries. When the same document appears multiple times through joins or derived views, the semantic mismatch becomes visible immediately.
Follow-up 3. Curveball. Why do these issues often escape testing?
Answer: because testing usually validates interface execution, not business meaning. If totals are not deeply reconciled across systems, semantic duplication can go unnoticed until finance performs period-end analysis.
Exclusive pro tip.
Treat all compatibility views as temporary scaffolding. Any interface still reading BSEG after migration is a future audit issue waiting to happen.
Scenario 2. Field length extensions break flat file interfaces.
After migrating to S/4HANA, file-based interfaces that exchange master or transactional data with external systems start failing intermittently. Some files are rejected, others load but produce corrupted values. From the business side, the data looks randomly wrong even though the interface logic itself was not changed.
Scenario analysis and root cause.
This failure is confusing because the interface technically still runs. 1. S/4HANA introduces mandatory field length extensions such as MTNR, KUNNR, LIFNR, and document numbers. 2. Legacy flat files were designed with fixed length assumptions from ECC. 3. During migration, the backend accepts longer values but outbound files truncate or misalign fields. 4. Key insight: the interface structure is no longer aligned with the S/4HANA data model.
Why this is a migration-exclusive failure.
1. ECC allowed shorter field lengths that external systems hard-coded. 2. S/4HANA enforces extended field lengths system-wide. 3. Migration upgrades backend structures but does not automatically update external file definitions. 4. This mismatch only appears once real S/4HANA data flows through the interface.
Ownership, integration-led, data and ABAP support required.
This issue cannot be solved by changing the interface mapping alone. 1. Integration consultant identifies impacted interfaces and external dependencies. 2. ABAP team updates extraction logic and outbound structures to handle extended fields. 3. Data team validates migrated master data length and content. 4. External system owners adjust file parsers and validations. 5. Project leadership coordinates cross-system change approvals.
How this is actually fixed, the right way by a role.
1. Integration team inventories all flat file interfaces impacted by extended fields. 2. ABAP team adjusts file layouts and extraction logic to use extended domain lengths. 3. Data team validates that migrated values fit the new target structures. 4. External teams update consuming systems to accept longer values. 5. Leadership enforces synchronized transport and deployment across landscapes.
What not to do, common wrong fixes.
1. Truncating fields to match old ECC file layouts. 2. Manually padding or cutting values in the interface. 3. Assuming only master data interfaces are affected. 4. Fixing one interface without checking similar patterns elsewhere.
Follow-up 1. Why do some files work while others fail?
Answer: only records that contain extended values trigger the failure. If test data uses short values, the interface appears stable. Real production data exposes the structural mismatch immediately.
Follow-up 2. Why is this often missed during testing?
Answer: testing environments frequently contain legacy-sized data. Without explicitly validating maximum field lengths, the interface passes functional tests but fails under real production conditions.
Follow-up 3. Curveball. Why is truncation considered a critical audit risk?
Answer: truncation silently changes business meaning. Once truncated data is sent to external systems, reconciliation becomes impossible and auditors lose traceability between source and target values.
Exclusive pro tip.
Treat every flat file interface as a high-risk object during migration. If it was built with fixed positions in ECC, assume it is broken until proven otherwise in S/4HANA.
Scenario 3. Header item semantic changes break mapping logic.
After S/4HANA migration, inbound or outbound interfaces that map accounting documents begin producing incorrect results. Some documents appear duplicated, others miss line items, and downstream systems report inconsistent balances. Technically, the interface completes successfully, but business reconciliation fails.
Scenario analysis and root cause.
This issue is confusing because document numbers and posting dates still exist. 1. ECC interfaces relied on clear separation between header tables and item tables. 2. S/4HANA consolidates financial data into ACDOCA with extended dimensions. 3. Legacy mapping logic assumes one-to-one header-item relationships that no longer hold. 4. Key insight: the business meaning of a line item has changed, not just its location.
Why this is a migration-exclusive failure.
1. ECC stored financial semantics across multiple physical tables. 2. S/4HANA flattens and enriches accounting dimensions in a single journal. 3. Migration keeps old join logic technically executable but semantically wrong. 4. This mismatch never existed before S/4HANA's unified data model.
Ownership, integration-led multi-team fix.
This problem cannot be resolved by adjusting mappings alone. 1. Integration consultant identifies incorrect header item assumptions in interface mappings. 2. ABAP team redesigns data extraction using S/4HANA release structures or CDS views. 3. FICO consultant clarifies which dimensions are required for financial meaning. 4. Data team validates historical and current data consistency. 5. Project leadership approves semantic redesign instead of quick technical patches.
How this is actually fixed, the right way by a role.
1. Integration team redefines document mapping based on business meaning, not table structure. 2. ABAP team replaces ECC-style joins with ACDOC-aligned data access. 3. FICO team validates which line item dimensions are mandatory for reporting. 4. Data team performs reconciliation across old and new semantic models. 5. Leadership ensures interface redesign is treated as mandatory migration work.
What not to do, common wrong fixes.
1. Adding more join conditions to force old behavior. 2. Filtering out records to match expected counts. 3. Blaming ACDOCA volume for incorrect totals. 4. Keeping legacy mapping logic for short-term comfort.
Follow-up 1. Why does duplication appear only in some documents?
Answer: documents with additional dimensions such as profitability segments or parallel ledgers generate multiple semantic line items in ACDOCA. Legacy logic treats these as duplicates instead of distinct business records.
Follow-up 2. How do you explain this to business users?
Answer: by showing that the document is financially correct in S/4HANA but represented differently. The issue is not wrong data, but outdated assumptions about how accounting meaning is stored.
Follow-up 3. Curveball. Why is this more dangerous than a technical failure?
Answer: because the interface succeeds technically while silently corrupting financial meaning. This creates long-term trust issues and audit risks without triggering immediate alerts.
Exclusive pro tip.
Any interface that assumes one accounting document equals one business meaning is already wrong in S/4HANA. Redesign for semantics, not structure.
Category 2 wrap-up. when data is technically right but semantically wrong.
Core data model failures prove that S/4HANA migration errors are no longer loud or obvious. Interfaces continue to run, reports continue to load, but the financial meaning silently drifts. These are the most dangerous failures because they undermine trust without triggering alarms.
Transition, when faster systems behave worse.
With data meaning corrected, projects expect stability to improve. Instead, many interfaces become slower, less predictable, or fail under load. The root cause is not performance. It is timing, parallelism, and execution assumptions that no longer hold in S/4HANA.
Please check description or comments section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP job interviews like SAP Master Data Governance MDG Consultant Jobs, SAP Business Technology Platform BTP Consultant Jobs, SAP Business Objects Data Services BODS Consultant Jobs, SAP Analytics Cloud SSC Consultant Jobs, SAP Cloud Platform Integration CPI Consultant Jobs, SAP S/4HANA Consultant Jobs, and SAP Functional Modules Interviews jobs like SAP Consultant Jobs, SAP FICO Consultant Jobs, SAP SD Consultant Jobs, SAP PP Consultant Jobs, SAP Ariba Consultant Jobs, SAP Extended Warehouse Management EWM Consultant Jobs, SAP Plant Maintenance PM Consultant Jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 3. Timing, parallelism, and performance shifts.
S/4HANA runs on a faster database, but speed changes behavior. Processes execute in parallel, jobs overlap, and transactions finish sooner than legacy logic expects. Interfaces built for sequential, batch-oriented ECC timing begin to fail in subtle and unpredictable ways.
Scenarios covered in Category 3.
1. Interfaces time out despite faster HANA backend, ownership, integration-led basis support. 2. Parallel execution exposes race conditions ownership, not an integration-only fix. 3. Background job-driven interfaces overlap after migration, ownership, integration-led basis support.
Scenario 9. Interfaces time out despite faster HANA backend.
After migrating to S/4HANA, business and IT expect interfaces to run faster due to the HANA database. Instead, critical interfaces begin timing out, especially under peak load. CPI shows retries, background jobs run longer than before, and users report delays even though system performance metrics look healthy.
Scenario analysis and root cause.
This issue is counterintuitive because the backend is objectively faster. 1. HANA executes database operations faster, allowing more transactions to run in parallel. 2. Interfaces and jobs that were sequential in ECC now overlap in execution. 3. External systems, middleware, or RFC connections become the new bottleneck. 4. Key insight: end-to-end performance is limited by the slowest component, not the database.
Why this is a migration-exclusive failure.
1. ECC performance naturally throttled execution due to slower database processing. 2. S/4HANA removes this implicit throttling without redesigning interface flow. 3. Timeout settings in middleware and RFC destinations remain sized for ECC behavior. 4. The failure appears only after migration, without any functional change to the interface.
Ownership, integration-led, basis support.
This is not a pure basis tuning issue nor an application defect. 1. Integration consultant identifies end-to-end flow timing and external dependencies. 2. Basis team reviews RFC, HTTP, and background job timeout configurations. 3. ABAP team confirms no unnecessary serialization or long-running logic exists. 4. External system owners validate inbound processing capacity. 5. Project leadership prevents sign-off based solely on back-end performance metrics.
How this is actually fixed, the right way by a role.
1. Integration team redesigns flows to manage concurrency instead of assuming sequential execution. 2. Basis team adjusts timeout thresholds based on real S/4HANA execution patterns. 3. ABAP team optimizes commit points and reduces unnecessary synchronous calls. 4. External systems scale processing capacity or switch to asynchronous consumption. 5. Leadership enforces performance testing under realistic parallel load conditions.
What not to do, common wrong fixes.
1. Blindly increasing timeout values without flow analysis. 2. Assuming HANA performance guarantees interface stability. 3. Blaming middleware without validating backend execution patterns. 4. Reducing data volume to mask concurrency issues.
Follow-up 1. Why didn't this happen in ECC?
Answer: ECC slower execution, unintentionally serialized processing. S/4HANA removes that delay, exposing concurrency limits that were always present but never reached before.
Follow-up 2. Is this a performance tuning problem or an architecture problem?
Answer: it is primarily an architectural problem. Tuning helps, but without redesigning concurrency assumptions, timeouts will resurface under load.
Follow-up 3. Curveball. Why do performance dashboards look green while users complain?
Answer: because dashboards measure system health in isolation. Users experience end-to-end process delays, which include external systems, middleware queues, and timeout thresholds not visible in standard monitoring.
Exclusive pro tip.
Never evaluate S/4HANA interface performance inside SAP alone. Real performance is defined by the slowest external dependency, not the fastest database.
Scenario 10. Parallel execution exposes race conditions.
After migrating to S/4HANA, interfaces that previously ran reliably begin to behave inconsistently. Some transactions succeed, others fail sporadically, and reprocessing the same data sometimes works without changes. The failures cannot be reproduced easily and appear random to both IT and business users.
Scenario analysis and root cause.
This issue is difficult to diagnose because no single component is broken. 1. S/4HANA executes transactions and background tasks in far greater parallelism than ECC. 2. Legacy logic assumes sequential processing and shared data states. 3. Multiple processes attempt to update or read the same business objects simultaneously. 4. Key insight: race conditions were always present, but ECC never ran fast enough to expose them.
Why this is a migration-exclusive failure.
1. ECC's slower execution naturally serialized access to shared data. 2. S/4HANA removes this implicit sequencing through parallel execution. 3. Migration preserves legacy assumptions about processing order. 4. These conditions only surface when speed and concurrency increase simultaneously.
Ownership, not an integration-only fix.
This problem spans multiple technical layers and cannot be solved in isolation. 1. Integration consultant identifies conflicting flows and overlapping execution paths. 2. ABAP team reviews locking logic, update tasks, and commit sequencing. 3. Basis team analyzes job parallelism and work process configuration. 4. Data team detects inconsistent object states caused by concurrent updates. 5. Leadership accepts that redesign is required instead of quick retries.
How this is actually fixed, the right way by a role.
1. Integration team redesigns flows to avoid simultaneous updates of the same objects. 2. ABAP team implements proper locking and transactional boundaries. 3. Basis team limits uncontrolled parallel job execution where sequencing is required. 4. Data team validates object state consistency after concurrent processing. 5. Leadership mandates concurrency testing as part of migration validation.
What not to do, common wrong fixes.
1. Retrying failed messages without addressing concurrency. 2. Assuming inconsistent behavior is caused by data quality. 3. Reducing parallelism globally without understanding dependencies. 4. Treating race conditions as one-off defects.
Follow-up 1. Why are these issues so hard to reproduce?
Answer: because race conditions depend on timing rather than data. Slight differences in system load, user activity, or background processing can change execution order. This makes the same input succeed once and fail the next time, even though nothing appears to change.
Follow-up 2. Why didn't testing catch this before go live?
Answer: test environments rarely simulate true production parallelism. Jobs are often run sequentially, volumes are smaller, and user concurrency is low. Without stress and concurrency testing, race conditions remain hidden until real usage begins.
Follow-up 3. Curveball. Why is this not just a performance tuning issue?
Answer: because tuning does not change execution order assumptions. Race conditions are logic flaws caused by shared state and missing locks. Increasing hardware or adjusting parameters may reduce frequency, but will not eliminate the underlying risk.
Exclusive pro tip.
If an interface behaves differently each time it runs with the same data, suspect a race condition first, not bad data or unstable middleware.
Scenario 11. Background job-driven interfaces overlap after migration.
After S4 HANA migration, interfaces triggered by background jobs begin to interfere with each other. Jobs that were carefully sequenced in ECC now overlap, run in parallel, or start earlier than expected. Business users report duplicated outputs, partial data loads, or missing records even though each job itself completes successfully.
Scenario analysis and root cause.
This failure happens because job timing assumptions silently change after migration. 1. ECC job runtimes were longer and implicitly enforced sequencing between dependent jobs. 2. S4 HANA executes jobs faster, causing dependent jobs to start earlier or overlap. 3. Legacy scheduling logic assumes completion based on time windows, not actual job status. 4. Key insight: faster execution breaks time-based dependency assumptions.
Why this is a migration-exclusive failure.
1. ECC landscapes relied heavily on time-based batch chains. 2. S4 HANA changes execution duration without changing job definitions. 3. Migration preserves schedules but not the assumptions behind them. 4. These overlaps appear only when runtime characteristics fundamentally change.
Ownership, integration-led, basis support.
This issue requires coordination between integration design and job scheduling. 1. Integration consultant identifies interface dependencies across job chains. 2. Basis team reviews job scheduling, start conditions, and event-based triggers. 3. ABAP team confirms job logic does not assume exclusive execution windows. 4. Data team validates that partial job outputs do not corrupt downstream systems. 5. Leadership enforces redesign of batch chains instead of relying on legacy timing.
How this is actually fixed, the right way by a role.
1. Integration team defines explicit dependencies instead of time-based assumptions. 2. Basis team converts job chains to event-driven or status-based scheduling. 3. ABAP team adds safeguards to prevent overlapping execution where unsafe. 4. Data team validates end-to-end batch completeness before downstream consumption. 5. Leadership mandates batch chain redesign as part of migration scope.
What not to do, common wrong fixes.
1. Adding arbitrary delays between jobs. 2. Assuming faster jobs automatically means safer execution. 3. Manually restarting failed or overlapping jobs without analysis. 4. Keeping ECC-era schedules unchanged after migration.
Follow-up 1. Why did these job overlaps never occur in ECC?
Answer: in ECC, slower runtimes unintentionally enforced spacing between jobs. One job often finished just in time for the next to start. S4 HANA removes this delay, allowing jobs to collide unless dependencies are explicitly defined.
Follow-up 2. Why is relying on start times risky after migration?
Answer: start times assume predictable runtimes, which no longer exist after moving to HANA. Execution speed can vary with load and parallelism. Without status-based dependencies, jobs may start before prerequisite data is complete.
Follow-up 3, curveball. Why do these issues often appear only weeks after go-live?
Answer: because batch overlaps depend on volume, load, and calendar effects. Period-end processing, higher data volumes, or new parallel jobs slowly push schedules into unsafe overlap. This delayed onset makes root cause harder to trace.
Exclusive pro tip.
Any batch chain that depends on clock time instead of job completion is already broken in S/4HANA. Migration just exposes it.
Category 3 wrap-up. When speed breaks stability.
Timing and performance failures prove that S/4HANA speed is not automatically beneficial. Faster execution removes natural safeguards that ECC relied on for sequencing and stability. Without redesigning timing assumptions, integration landscapes become less predictable, not more reliable.
Transition from transaction accuracy to analytical truth.
Once transactional interfaces appear stable, attention shifts to reporting and analytics. This is where many projects discover a new class of failure: totals that don't reconcile, deltas that drift, and analytics that slowly diverge from operational reality.
Category 4, BW or BPC or analytics integration failures.
Analytics integrations depend on assumptions about data timing, structure, and aggregation. S/4HANA changes all three. When BW, BPC, or group reporting feeds are not redesigned for the new data model and execution behavior, reporting remains technically active but financially untrustworthy.
Scenarios covered in Category 4.
1. BW totals don't match S/4HANA post-migration ownership, integration-led multi-team fix. 2. Delta logic breaks after conversion, ownership, integration-led data team support. 3. BPC or group reporting feeds drift after go-live ownership, not an integration-only fix.
Scenario 12. BW totals don't match S/4HANA post-migration.
After S/4HANA migration, BW reports and reconciliation dashboards no longer match S/4HANA financial totals. Interfaces run successfully, data loads complete, and no technical errors are raised. However, finance users discover persistent differences between operational reports and analytical outputs.
Scenario analysis and root cause.
This issue is alarming because both systems appear technically correct. 1. BW extractors and interfaces were designed around ECC table structures and semantics. 2. S/4HANA introduces ACDOCA with additional dimensions, ledgers, and posting logic. 3. Legacy aggregation and transformation logic no longer aligns with S/4HANA financial meaning. 4. Key insight: BW is aggregating correct data, using outdated financial assumptions.
Why this is a migration-exclusive failure.
1. ECC and BW were historically aligned on table-based FI semantics. 2. S/4HANA changes the source model without forcing BW redesign. 3. Migration keeps extractors alive while silently changing data meaning. 4. This mismatch only appears after S/4HANA becomes the operational source of truth.
Ownership, integration-led multi-team fix.
No single team can resolve this discrepancy in isolation. 1. Integration consultant identifies misalignment between S/4 extractors and BW models. 2. BW team reviews transformations, info providers, and aggregation logic. 3. FICO consultant defines which totals are financially authoritative. 4. Data team performs reconciliation across operational and analytical layers. 5. Project leadership enforces analytical redesign instead of reconciliation workarounds.
How this is actually fixed, the right way by a role.
1. Integration team aligns BW extraction logic with S/4HANA released views or CDS sources. 2. BW team redesigns aggregation logic to reflect S/4HANA ledger and dimension behavior. 3. FICO team validates reconciliation rules based on S/4 financial semantics. 4. Data team performs parallel runs to confirm analytical correctness. 5. Leadership mandates BW remediation as part of migration completion.
What not to do, common wrong fixes.
1. Adjusting BW totals manually to match S/4 reports. 2. Hiding differences with reconciliation-only reports. 3. assuming BW inconsistencies are purely timing related. 4. Declaring BW out of scope for migration.
Follow-up 1. Why do BW totals look correct historically, but not after migration?
Answer: historical data was loaded using ECC semantics that BW was originally designed for. After migration, new postings follow S/4HANA rules, dimensions, and ledger logic. BW continues to process data as if nothing changed, causing divergence over time.
Follow-up 2. Why can't finance just reconcile BW to S/4HANA monthly?
Answer: manual reconciliation hides structural misalignment instead of fixing it. Over time, differences grow and require increasing manual effort. This approach also undermines confidence in analytics and creates audit and governance risks.
Follow-up 3. Curveball. Why do these issues often surface during audits?
Answer: audits compare analytical outputs against statutory financial reports. When BW logic does not reflect S/4HANA semantics, discrepancies become visible under scrutiny. By then, root causes are harder to isolate due to accumulated data.
Exclusive pro tip.
If BW does not reconcile with S/4HANA by design, it never will by effort. Fix the model, not the numbers.
Scenario 13. Delta logic breaks after conversion.
After S/4HANA migration, BW and downstream analytical systems begin reporting missing or duplicated records. Full loads appear correct, but delta loads drift over time. Interfaces complete successfully, yet cumulative totals slowly diverge from S/4HANA.
Scenario analysis and root cause.
This issue is deceptive because it only appears after multiple cycles. 1. ECC delta logic relied on change pointers and table-based timestamps. 2. S/4HANA consolidates postings in ACDOCA with different update behavior. 3. Legacy delta fields no longer represent true business changes. 4. Key insight delta mechanisms survived conversion, but their meaning did not.
Why this is a migration-exclusive failure.
1. ECC deltas were designed for physically stored tables. 2. S/4HANA uses logical views and unified journals. 3. Migration preserves delta logic without semantic validation. 4. Drift appears only after multiple delta cycles post-go-live.
Ownership, integration-led, data team support.
This is primarily a data semantics issue, not a transport failure. 1. Integration consultant identifies broken delta assumptions in interface design. 2. BW team reviews delta extractors and update rules. 3. Data team validates completeness across delta and full loads. 4. ABAP team supports redesign of delta logic if required. 5. Leadership approves delta redesign instead of repeated reloads.
How this is actually fixed. The right way by a role.
1. Integration team revalidates delta design against S/4HANA posting behavior. 2. BW team switches to S/4HANA release delta mechanisms or CDS-based deltas. 3. Data team performs controlled full reloads to rebaseline analytics. 4. ABAP team ensures delta-relevant fields reflect real business changes. 5. Leadership enforces delta certification before resuming incremental loads.
What not to do. Common wrong fixes.
1. Running frequent full reloads as a permanent solution. 2. Manually deleting suspected duplicates in BW. 3. Assuming delta drift is caused by timing delays. 4. Ignoring small discrepancies early on.
Follow-up 1. Why do deltas work initially after go-live?
Answer: early deltas operate on a clean baseline where changes are simple and limited. As business activity increases, more complex posting patterns emerge. Legacy delta logic cannot interpret these correctly, causing gradual divergence.
Follow-up 2. Why is full load correctness not a guarantee?
Answer: full loads bypass delta logic entirely, masking the underlying problem. Deltas apply business interpretation over time. If that interpretation is wrong, correctness decays even though full loads look accurate.
Follow-up 3. Curveball. Why do teams delay fixing delta issues?
Answer: because drift starts small and is easy to rationalize. Teams prioritize visible failures over subtle inconsistencies. By the time the issue is undeniable, data volume and complexity make correction far more expensive.
Exclusive pro tip.
If delta logic is not recertified after migration, It is broken by default, even if it appears to work on day one.
Scenario 14. BPC/group reporting feeds drift after go live.
After go live, BPC or group reporting outputs slowly begin to diverge from S/4HANA financial results. Initial close cycles appear correct, but over subsequent periods consolidation numbers, eliminations, or currency translations no longer align. Interfaces continue to run successfully, creating a false sense of stability.
Scenario analysis and root cause.
This failure is subtle and often blamed on process complexity rather than integration design. 1. BPC and group reporting rely on tightly controlled timing, hierarchies, and data finality. 2. S/4HANA introduces changes in posting behavior, ledger logic, and parallel processing. 3. Interfaces continue feeding data without respecting financial close milestones. 4. Key insight. Consolidation systems require finalized financial states, not transactional streams.
Why this is a migration-exclusive failure.
1. ECC landscape synchronized consolidation feeds around rigid close cycles. 2. S/4HANA enables continuous posting and late adjustments. 3. Migration preserves feed schedules without redefining close dependencies. 4. This misalignment only emerges once real close cycles repeat post-go-live.
Ownership, not an integration-only fix.
This issue spans integration, finance process design, and governance. 1. Integration consultant identifies misaligned feed timing and triggering logic. 2. FICO consultant defines true financial finalization points for consolidation. 3. BPC/group reporting team validates hierarchy, currency, and elimination logic. 4. Data team performs period-over-period reconciliation to detect drift early. 5. Leadership enforces governance over consolidation feed timing and approval.
How this is actually fixed, the right way by a role.
1. Integration team redesigns feeds to trigger only after financial close milestones. 2. FICO team documents and enforces clear close completion indicators. 3. BPC/group reporting team aligns consolidation logic with S/4HANA posting behavior. 4. Data team performs controlled parallel close runs during stabilization. 5. Leadership blocks automation until financial governance is fully aligned.
What not to do, common wrong fixes.
1. Manually adjusting consolidation numbers each period. 2. Running consolidation feeds multiple times to force alignment. 3. Blaming currency translation or eliminations without timing analysis. 4. Treating consolidation drift as a user training issue.
Follow-up 1. Why does consolidation drift worsen over time?
Answer: each close introduces adjustments, late postings, and corrections that were not present initially. When feeds do not respect finalization boundaries, small differences accumulate. Over several periods, these compound into visible and persistent mismatches.
Follow-up 2. Why can't consolidation systems self-correct?
Answer: consolidation tools assume that inbound data represents finalized financial truth. They do not reevaluate source system semantics on each load. Without correct timing and governance, they simply amplify upstream inconsistencies.
Follow-up 3. Curveball. Why is this often discovered during audits or board reporting?
Answer: audits and executive reporting force strict reconciliation across systems. At that point, inconsistencies can no longer be explained away as timing or rounding issues. The longer drift persists, the harder it becomes to restore trust.
Exclusive pro tip.
If consolidation feeds are not governed by financial close rules, analytics will always drift, no matter how reliable the interface looks.
Category 4 wrap-up. When analytics drift away from financial reality.
BW, BPC, and analytics failures demonstrate that reporting correctness is not guaranteed by technical success. When extraction logic, delta handling, and consolidation timing are not redesigned for S/4HANA, analytics slowly detach from operational truth. These failures are especially dangerous because they surface late and undermine executive trust.
Transition from internal consistency to external obligations.
Once internal systems appear aligned, the next failures emerge at the system boundaries. Banking partners, tax engines, and external authorities are far less forgiving. In these integrations, even small semantic changes can result in rejected payments, incorrect tax filings, or regulatory exposure.
Please check description or comments section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP job interviews like SAP Master Data Governance MDG Consultant Jobs, SAP Business Technology Platform BTP Consultant Jobs, SAP Business Objects Data Services BODS Consultant Jobs, SAP Analytics Cloud SSC Consultant Jobs, SAP Cloud Platform Integration CPI Consultant Jobs, SAP S4 HANA Consultant Jobs, and SAP Functional Modules Interviews jobs like SAP Consultant Jobs, SAP FICO Consultant Jobs, SAP SD Consultant Jobs, SAP PP Consultant Jobs, SAP Ariba Consultant Jobs, SAP Extended Warehouse Management EWM Consultant Jobs, SAP Plant Maintenance PM Consultant Jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 5. Banking, Tax, and External Engine Failures.
External integrations depend on strict formats, regulatory assumptions, and financial completeness. S4 HANA changes cash management, tax determination, and payment structures in ways that are invisible to interface monitoring. When these changes are not explicitly handled, failures propagate directly to banks, tax authorities, and third-party engines.
Scenarios covered in Category 5.
1. Banking interfaces break due to new cash management model, ownership, integration-led multi-team fix. 2. External tax engine receives incomplete payloads, ownership, integration-led multi-team fix. 3. Payment file formats change without interface awareness, ownership, integration-led FICO support.
Scenario 15. Banking interfaces break due to new cash management model.
After migrating to S4 HANA, banking interfaces that previously worked reliably begin failing or producing incorrect results. Payment runs complete, but bank statements fail to reconcile, cash positions look wrong, and some bank interfaces reject files without clear technical errors. From the integration perspective, nothing obvious has changed.
Scenario analysis and root cause.
This issue is often misdiagnosed as a bank-specific or format problem. 1. ECC cash management relied on classic FI tables and update logic. 2. S4 HANA introduces a new cash management and liquidity model with different data sources. 3. Banking interfaces continue to extract data using legacy assumptions. 4. Key insight: the interface is correct for ECC cash logic, not S4 HANA liquidity semantics.
Why this is a migration-exclusive failure.
1. ECC and banks were aligned on classic cash and payment structures. 2. S4 HANA changes how cash positions and flows are calculated internally. 3. Migration keeps legacy banking interfaces active without redesign. 4. The mismatch only appears once S4 HANA becomes the financial source of truth.
Ownership, integration-led multi-team fix.
Resolving this issue requires coordination beyond the integration layer. 1. Integration consultant identifies which banking interfaces rely on legacy cash logic. 2. FICO consultant explains S4 HANA cash management and liquidity behavior. 3. ABAP team refactors data extraction to use S/4HANA release sources. 4. External bank contacts validate expectations for cash and payment data. 5. Project leadership approves redesign instead of forcing ECC-compatible outputs.
How this is actually fixed, the right way by a role.
1. Integration team redesigns banking interfaces based on S/4HANA cash management data sources. 2. FICO team validates liquidity positions and payment logic against business expectations. 3. ABAP team switches extraction logic to S/4HANA released views and APIs. 4. External banks confirm acceptance of updated cash and payment structures. 5. Leadership enforces banking interface remediation as a go-live prerequisite.
What not to do, common wrong fixes.
1. Forcing S/4HANA cash data into ECC-style structures. 2. Blaming banks for rejecting technically valid files. 3. Applying manual adjustments to cash positions. 4. Ignoring reconciliation mismatches because payments still post.
Follow-up 1. Why do payments post but cash positions look wrong?
Answer: payments can post successfully while cash visibility relies on different logic. S/4HANA separates payment execution from liquidity calculation. If interfaces still read legacy cash tables, the numbers no longer represent real financial positions.
Follow-up 2. Why don't banks always reject incorrect cash data?
Answer: banks validate file structure and format, not internal financial meaning. As long as mandatory fields are present, files may be accepted. The real problem surfaces later during reconciliation and cash forecasting.
Follow-up 3. Curveball. Why is this often discovered by Treasury, not IT?
Answer: Treasury teams monitor liquidity and forecasting accuracy over time. They notice inconsistencies when cash positions no longer align with expectations. By then, the issue has already propagated across multiple interfaces.
Exclusive pro tip.
If cash visibility changes after migration, assume your banking interfaces are wrong until proven otherwise, not the Treasury process.
Scenario 16. External tax engine receives incomplete payloads.
After S/4HANA migration, tax calculations begin producing inconsistent or incorrect results in external tax engines. Interfaces run successfully, messages are accepted, and no technical errors are raised. However, tax amounts differ from expectations, exemptions are ignored, or audits reveal missing tax-relevant attributes.
Scenario analysis and root cause.
This issue is dangerous because tax engines trust the payload they receive. 1. ECC tax integration relied on table-based tax determination and derived values. 2. S/4HANA introduces new tax-relevant fields, condition logic, and document structures. 3. Legacy payload mappings omit newly required attributes. 4. Key insight: the payload is structurally valid but semantically incomplete for tax determination.
Why this is a migration-exclusive failure.
1. ECC tax engines consumed stable, long-standing payload definitions. 2. S/4HANA expands tax logic without breaking interface execution. 3. Migration upgrades tax behavior but not integration contracts. 4. Errors appear only when real S/4HANA tax scenarios are processed.
Ownership, integration-led multi-team fix.
Tax issues require joint ownership between IT and finance. 1. Integration consultant identifies missing or outdated tax fields and payloads. 2. FICO consultant defines mandatory tax attributes and business rules. 3. ABAP team adjusts extraction logic to include new S/4HANA tax fields. 4. External tax vendor confirms required payload structure and validation rules. 5. Leadership treats tax interface remediation as compliance critical.
How this is actually fixed, the right way by a role.
1. Integration team redesigns tax payloads based on S/4HANA tax determination logic. 2. FICO team validates tax outcomes across representative business scenarios. 3. ABAP team exposes required tax attributes through released views or APIs. 4. External tax vendors update validation to reflect new payload semantics. 5. Leadership enforces end-to-end tax validation before sign-off.
What not to do, common wrong fixes.
1. Hard-coding default tax values to force calculation. 2. Suppressing tax warnings to allow posting. 3. Assuming tax errors are configuration-only issues. 4. fixing individual cases without payload redesign.
Follow-up 1. Why do tax engines accept incomplete payloads?
Answer: tax engines validate structure, not business completeness. If required fields are technically present but semantically insufficient, calculations still run. The error appears in incorrect tax results, not interface failures.
Follow-up 2. Why is this often discovered during audits?
Answer: audits review tax outcomes against statutory rules, not interface logs. Incomplete payloads may produce acceptable-looking results for common cases, but edge cases expose missing attributes under audit scrutiny.
Follow-up 3. Curveball. Why can't tax logic be replicated in middleware?
Answer: tax logic is jurisdiction-specific, frequently changing, and deeply embedded in S/4HANA and tax engines. Replicating it in middleware creates unsustainable duplication and high compliance risk.
Exclusive pro tip.
If a tax interface has not been redesigned for S/4HANA, assume it is non-compliant, even if postings succeed.
Scenario 17. Payment file formats change without interface awareness.
After S/4HANA migration, payment files sent to banks or payment processors begin failing sporadically or are accepted but processed incorrectly. Payment runs complete successfully in SAP, yet banks report rejected files, missing fields, or incorrect interpretation of payment details. Integration monitoring remains green, masking the real issue.
Scenario analysis and root cause.
This issue is often misattributed to bank-side changes or network problems. 1. S/4HANA introduces changes to payment medium formats and field usage. 2. Some payment fields are extended, restructured, or populated differently than in ECC. 3. Legacy interface logic assumes ECC-era payment file semantics. 4. Key insight: the file format may look the same, but the meaning of fields has changed.
Why this is a migration-exclusive failure.
1. ECC payment files followed long-established, stable conventions. 2. S/4HANA updates payment processing without forcing external interface redesign. 3. Migration keeps payment formats technically valid but semantically altered. 4. Failures emerge only when banks process real S/4HANA-generated files.
Ownership, integration-led FICO support.
This issue requires close coordination between integration and finance. 1. Integration consultant identifies differences between ECC and S/4HANA payment outputs. 2. FICO consultant explains changes in payment logic and field population. 3. ABAP team reviews payment medium programs and enhancements. 4. External banks validate expected payment file semantics. 5. Project leadership approves remediation timelines to avoid payment disruption.
How this is actually fixed. The right way by a role.
1. Integration team performs detailed file-level comparison between ECC and S4 outputs. 2. FICO team validates payment field usage against bank specifications. 3. ABAP team updates payment medium logic or format trees as required. 4. Banks confirm acceptance of revised formats in controlled testing. 5. Leadership enforces end-to-end payment testing before production cutover.
What not to do. Common wrong fixes.
1. Resending failed files without format analysis. 2. Manually editing payment files before sending to banks. 3. Assuming bank rejections are temporary connectivity issues. 4. Bypassing standard payment programs with custom scripts.
Follow-up 1. Why do banks sometimes accept incorrect payment files?
Answer: banks validate structural compliance first, not full semantic correctness. As long as mandatory fields exist, files may be accepted. Processing errors or misinterpretation often surface later during settlement or reconciliation.
Follow-up 2. Why is this often discovered during month-end or payroll runs?
Answer: high volume or critical runs use more complex payment scenarios. These stress rarely used fields and formats. Problems remain hidden during routine payments but become obvious under peak or sensitive processing cycles.
Follow-up 3. Curveball. Why are payment issues considered integration failures, not banking issues?
Answer: because the responsibility lies in delivering correct, agreed-upon file semantics. Banks process what they receive. If the interface sends data with changed meaning, the failure originates in integration design, not external processing.
Exclusive pro tip.
Never assume payment formats survive migration unchanged. Treat every bank interface as new when moving to S/4HANA.
Category 5 Wrap-up. When external systems stop being forgiving.
Banking, tax, and external engine failures prove that integration mistakes have real-world consequences. Unlike internal systems, external partners do not adapt to SAP migrations. When interfaces are not redesigned for S/4HANA semantics, failures surface as rejected payments, incorrect taxes, and regulatory exposure.
Transition from business failures to access failures.
As business logic stabilizes, a different class of issues emerges. Connections work, messages flow, and endpoints respond, yet transactions fail. These are security and connectivity failures where access rules, trust relationships, and authorizations no longer align after migration.
Category 6 Security and connectivity failures.
S/4HANA migration changes users, roles, certificates, and trust models. Interfaces may connect successfully, but fail during execution due to missing authorizations or broken trust. These issues are difficult to diagnose because they sit between basis, security, and integration ownership.
Scenarios covered in Category 6.
1. RFC destinations work, but authorizations fail ownership, not an integration-only fix. 2. HTTPS or certificate failures after conversion, ownership, basis-led integration support. 3. Trusted RFC relationships break post-migration ownership, not an integration-only fix.
Scenario 18. RFC destinations work, but authorizations fail.
After S/4HANA migration, RFC destinations test successfully and connections validate without errors. However, when interfaces execute business transactions, they fail with authorization errors. From an integration perspective, the connection is up, yet functional processing is blocked.
Scenario analysis and root cause.
This issue is misleading because technical connectivity appears intact. 1. RFC connection tests validate network and log on, not business authorizations. 2. S/4HANA introduces new authorization objects and tighter security checks. 3. Legacy service users retain ECC-era roles that no longer cover S/4 transactions. 4. Key insight: successful RFC connectivity does not guarantee execution authority.
Why this is a migration-exclusive failure.
1. ECC authorization models were looser and heavily role reused. 2. S/4HANA enforces more granular and business-aligned authorizations. 3. Migration copies users and roles without semantic revalidation. 4. Failures surface only when S/4-specific checks are executed.
Ownership, not an integration-only fix.
Resolving this issue requires coordinated security ownership. 1. Integration consultant identifies which business calls fail despite valid RFCs. 2. Security team reviews missing or obsolete authorization objects. 3. Basis team confirms service user setup and logon configuration. 4. ABAP team traces authorization checks executed during interface runs. 5. Leadership prevents role reuse without S/4 validation.
How this is actually fixed. The right way by a role.
1. Integration team identifies exact business functions executed by interfaces. 2. Security team redesigns roles based on S/4 authorization concepts. 3. ABAP team supports authorization trace analysis to pinpoint failures. 4. Basis team ensures service users are isolated and correctly assigned. 5. Leadership enforces role redesign instead of quick authorization patches.
What not to do. Common wrong fixes.
1. Granting SAP_all or overly broad roles to service users. 2. Assuming connection tests prove end-to-end readiness. 3. Copying ECC roles without S/4HANA review. 4. Ignoring authorization failures as transient issues.
Follow-up 1. Why does the RFC test succeed but the interface fail?
Answer: RFC tests only validate that a user can log on and establish a session. Business execution triggers deeper authorization checks tied to specific objects and activities. These checks often change in S/4HANA and are not covered by basic connection tests.
Follow-up 2. Why didn't this break immediately after go-live?
Answer: only certain transactions or data paths trigger the missing authorizations. Early usage may not hit those paths. As volume and functional coverage increase, the missing permissions surface under real business scenarios.
Follow-up 3. Curveball. Why is this considered a governance issue?
Answer: because roles define what systems are allowed to do. Allowing interfaces to run with copied or overly broad roles creates security risk. Proper governance ensures access is deliberate, minimal, and aligned with S4 business behavior.
Exclusive pro tip.
If an interface user was copied from ECC without redesign, assume its authorizations are wrong in S4 HANA, even if it connects successfully.
Scenario 19. HTTPS or certificate failures after conversion.
After S4 HANA migration, HTTPS-based integrations begin failing intermittently or stop working entirely. Endpoints that were reachable in ECC suddenly return SSL handshake errors, certificate validation failures, or trust issues. From the integration layer, messages are sent correctly, but secure connections are rejected.
Scenario analysis and root cause.
This issue is often misinterpreted as an external system or network problem. 1. S4 HANA systems are frequently rebuilt with new kernel versions and cryptographic libraries. 2. Certificate stores, and trust chains are not always migrated correctly from ECC. 3. Stricter TLS versions and cipher requirements are enforced by default. 4. Key insight: connectivity fails because trust models change, not because endpoints are wrong.
Why this is a migration-exclusive failure.
1. ECC systems often ran on older kernels with relaxed SSL requirements. 2. S4 HANA enforces modern security standards by default. 3. Migration recreates technical components without revalidating certificates. 4. Failures surface only when secure communication is attempted.
Ownership, basis-led, integration support.
Certificate and HTTPS failures sit primarily with basis and security teams. 1. Basis team manages PSEs, certificate stores, and SSL configuration. 2. Security team defines approved protocols, ciphers, and trust chains. 3. Integration consultant identifies affected interfaces and endpoints. 4. External partners provide updated certificates and security requirements. 5. Leadership prioritizes security remediation over temporary bypasses.
How this is actually fixed, the right way by a role.
1. Basis team rebuilds and validates certificate stores for S4 HANA. 2. Security team aligns TLS and cipher settings with external partners. 3. Integration team retests all HTTPS endpoints end-to-end. 4. External systems update certificates or protocols if required. 5. Leadership enforces security compliance instead of disabling checks.
What not to do, common wrong fixes.
1. Disabling SSL validation to restore connectivity. 2. Using self-signed certificates in production. 3. Ignoring certificate expiry and renewal processes. 4. Assuming one HTTPS fix applies to all interfaces.
Follow-up 1. Why do certificates suddenly fail after migration?
Answer: migration often involves new kernels, operating systems, and crypto libraries. These enforce stricter validation rules than ECC. Certificates that were previously accepted may no longer meet modern security requirements.
Follow-up 2. Why do some HTTPS interfaces work while others fail?
Answer: different endpoints use different certificates, trust chains, and protocols. Some comply with modern standards while others rely on outdated algorithms. Migration exposes these inconsistencies immediately.
Follow-up 3. Curveball. Why is bypassing SSL checks a serious risk?
Answer: disabling SSL validation removes protection against man-in-the-middle attacks. While it may restore connectivity temporarily, it exposes sensitive financial and personal data and violates security and compliance standards.
Exclusive pro tip.
If HTTPS breaks after migration, assume your security baseline has changed, not that the partner system is suddenly wrong.
Scenario 20. Trusted RFC relationships break post-migration.
After S4 HANA migration, trusted RFC connections between SAP systems stop working as expected. RFC destinations test successfully at a basic level, but cross-system calls fail with authorization or trust errors. Interfaces that relied on trusted logons in ECC begin failing without obvious configuration changes.
Scenario analysis and root cause.
This failure is confusing because no credentials appear to be wrong. 1. Trusted RFCs rely on security relationships, not passwords. 2. S/4HANA enforces stricter trust validation and user mapping rules. 3. Migration recreates systems without re-establishing trust metadata correctly. 4. Key insight: trust relationships do not survive migration unless explicitly rebuilt.
Why this is a migration-exclusive failure.
1. ECC trusted RFCs were often configured once and left untouched for years. 2. S/4HANA migrations rebuild system identities and security contexts. 3. Trust configurations are not automatically validated or migrated. 4. Failures surface only when trusted calls are executed in production.
Ownership, not an integration-only fix.
Trusted RFC issues span security basis and governance boundaries. 1. Integration consultant identifies interfaces relying on trusted RFC behavior. 2. Security team reestablishes trust relationships and user mappings. 3. Basis team validates system IDs, RFC destinations, and logon groups. 4. ABAP team traces authorization failures during trusted calls. 5. Leadership enforces controlled trust setup instead of legacy reuse.
How this is actually fixed, the right way by a role.
1. Security team rebuilds trusted RFC relationships explicitly in S/4HANA. 2. Basis team validates system identities and destination configuration. 3. Integration team retests all trusted calls end-to-end. 4. ABAP team adjusts logic where implicit trust assumptions existed. 5. Leadership enforces documentation and approval of all trust relationships.
What not to do, common wrong fixes.
1. Switching trusted RFCs to hard-coded technical users without review. 2. Granting excessive authorizations to bypass trust errors. 3. Assuming trust configurations migrated automatically. 4. Ignoring trust failures because basic RFC tests pass.
Follow-up 1. Why do trusted RFCs fail even though no passwords changed?
Answer: trusted RFCs do not rely on passwords. They depend on system identity, certificates, and user mappings. Migration rebuilds these technical identities, breaking trust unless it is explicitly reconfigured.
Follow-up 2. Why is this often discovered late?
Answer: trusted RFCs are frequently used in background or exception flows. These paths are not exercised during basic testing. Failures appear only when specific business scenarios invoke trusted calls.
Follow-up 3. Curveball. Why are trusted RFCs considered a security risk?
Answer: trusted RFCs bypass explicit authentication by design. If not governed carefully, they allow uncontrolled cross-system access. S/4HANA enforces stricter rules to reduce this risk.
Exclusive pro tip.
If a trusted RFC was created years ago and never reviewed, assume it is invalid after migration and potentially unsafe even if it works.
Category 6 wrap-up. When access breaks after everything looks connected.
Security and connectivity failures reveal a dangerous illusion of readiness. Interfaces connect, destinations test, and certificates exist, yet execution fails. These issues arise because S/4HANA migration reshapes trust, authorization, and security boundaries that were never formally governed in ECC.
Transition from design failures to execution blind spots.
Even well-designed integrations fail if they are never tested under real conditions. As projects approach go-live, time pressure shifts focus from correctness to completion. This is where testing gaps and cutover shortcuts quietly introduce the most expensive failures.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP job interviews like SAP Master Data Governance MDG Consultant Jobs, SAP Business Technology Platform BTP Consultant Jobs, SAP Business Objects Data Services BODS Consultant Jobs, SAP Analytics Cloud SSC Consultant Jobs, SAP Cloud Platform Integration CPI Consultant Jobs, SAP S/4HANA Consultant Jobs. And SAP Functional Modules interviews jobs like SAP Consultant jobs, SAP FICO Consultant jobs, SAP SD Consultant jobs, SAP PP Consultant jobs, SAP Ariba Consultant jobs, SAP Extended Warehouse Management EWM Consultant jobs, SAP Plant Maintenance PM Consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving. Interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 7. Testing and cutover blind spots.
Testing failures are rarely technical mistakes. They are planning failures. Interfaces work in isolation, but collapse under real volumes, real timing, and real cut over pressure. S4 HANA migration amplifies these risks by changing data scale, execution speed, and dependency chains.
Scenarios covered in Category 7.
1. Interfaces tested only with small data volumes, ownership, integration-led testing support. 2. Cutover sequence breaks interface dependencies, ownership, not an integration-only fix. 3. Emergency interface fixes create long-term instability, ownership, integration-led, governance required.
Scenario 21. Interfaces tested only with small data volumes.
Before go live, interfaces pass all functional tests and sign-off is granted. Shortly after production cutover, interfaces begin failing, slowing down, or producing inconsistent results. The root cause is not a logic error, but the fact that testing never reflected real production data volumes.
Scenario analysis and root cause.
This issue is common because volume testing is often deprioritized. 1. Test environments usually contain limited or sanitized datasets. 2. Interfaces are validated for correctness, not scalability. 3. S4 HANA enables higher throughput, exposing downstream bottlenecks. 4. Key insight: volume-related failures are invisible in functional testing.
Why this is a migration-exclusive failure.
1. ECC data volumes grew gradually over years. 2. S4 HANA cutovers often introduce full-scale data immediately. 3. Migration resets volume assumptions overnight. 4. Interfaces fail when real production scale is applied suddenly.
Ownership, integration-led, testing support.
This failure stems from testing strategy, not development quality. 1. Integration consultant identifies interfaces sensitive to volume and throughput. 2. Testing team designs volume and stress test scenarios. 3. Basis team monitors system resource behavior under load. 4. Data team provides representative datasets for testing. 5. Leadership approves testing scope that includes volume realism.
How this is actually fixed, the right way by a role.
1. Integration team executes volume and stress tests using production-like data. 2. Testing team validates end-to-end throughput, not just success status. 3. Basis team tunes resources based on observed load patterns. 4. Data team ensures test data reflects real distribution and size. 5. Leadership enforces volume testing as a go-live prerequisite.
What not to do, common wrong fixes.
1. Assuming performance tuning after go-live will solve everything. 2. Reducing data volumes to make interfaces pass. 3. Treating early failures as temporary stabilization issues. 4. Skipping volume tests due to time pressure.
Follow-up 1. Why do interfaces work fine initially but fail later?
Answer: initial runs often process limited datasets or low concurrency. As business activity ramps up, interfaces encounter volumes and patterns never tested. This exposes scalability limits that were invisible during validation.
Follow-up 2. Why isn't functional testing enough?
Answer: functional testing validates correctness, not capacity. An interface can be logically correct but incapable of handling production-scale data. Without volume testing, this risk remains hidden until go live.
Follow-up 3. Curveball. Why do teams resist volume testing?
Answer: volume testing requires realistic data, longer execution windows, and cross-team coordination. Under schedule pressure, teams prioritize visible progress over risk reduction. Unfortunately, volume-related failures are among the most disruptive post-go-live.
Exclusive pro tip.
If an interface has never processed production-sized data before go-live, it has not been tested. It has only been demonstrated.
Scenario 22. Cutover sequence breaks interface dependencies.
During cutover, interfaces that worked in testing suddenly fail or produce inconsistent results. Master data arrives after transactional data, dependent systems start too early, or background jobs run before prerequisites are in place. Individually, each interface behaves correctly. Collectively, the sequence is broken.
Scenario analysis and root cause.
This issue emerges from coordination gaps rather than technical defects. 1. Interfaces are tested in isolation, not as part of a full cutover chain. 2. Cutover plans focus on system readiness, not data and interface dependencies. 3. S4 HANA processes execute faster, amplifying sequencing errors. 4. Key insight: correct interfaces fail when executed in the wrong order.
Why this is a migration-exclusive failure.
1. ECC cutovers evolved gradually with long stabilization windows. 2. S4 HANA migrations often compress cutover timelines dramatically. 3. Migration introduces new dependencies between modernized components. 4. Sequence failures appear only during real cutover execution.
Ownership, not an integration-only fix.
Cutover failures require cross-team orchestration. 1. Integration consultant maps interface dependencies and execution order. 2. Cutover team defines and enforces runbooks and sequencing. 3. Data team confirms master and transactional data readiness. 4. Basis team controls job scheduling and system availability. 5. Leadership owns cutover governance and decision-making.
How this is actually fixed. The right way by a role.
1. Integration team documents explicit interface dependency chains. 2. Cutover team executes multiple DRY runs with full sequencing. 3. Data team validates data readiness checkpoints before interface start. 4. Basis team controls job release timing during cutover. 5. Leadership enforces go/no-go decisions based on dependency readiness.
What not to do. Common wrong fixes.
1. Restarting interfaces blindly during cutover. 2. Allowing teams to trigger interfaces independently. 3. Assuming issues will resolve after stabilization. 4. Skipping cutover rehearsals to save time.
Follow-up 1. Why do cutover issues rarely appear in testing?
Answer: testing environments usually do not simulate full cutover pressure, parallel activities, or compressed timelines. Interfaces are validated one by one, not as a coordinated chain. The real dependency issues only surface when everything runs together.
Follow-up 2. Why can't teams just fix issues as they arise?
Answer: because cutover time is limited and highly interdependent. Fixing one issue can block others or corrupt data order. Without a predefined sequence, reactive fixes increase risk rather than reduce it.
Follow-up 3. Curveball. Why is cutover governance more important than tooling?
Answer: tools execute tasks, but governance controls order and decision-making. Most cutover failures are not caused by missing tools, but by unclear ownership and sequencing authority under pressure.
Exclusive pro tip.
If interface dependencies are not written into the cutover runbook, they will be violated during go-live.
Scenario 23. Emergency interface fixes create long-term instability.
During cutover or early stabilization, interfaces fail under pressure and emergency fixes are applied to restore operations quickly. These changes are often undocumented, partially tested, or implemented directly in production. While the immediate issue is resolved, the integration landscape becomes fragile and unpredictable over time.
Scenario analysis and root cause.
This issue is driven by urgency rather than poor technical skill. 1. Cutover pressure prioritizes restoration over correctness. 2. Emergency fixes bypass normal design, testing, and governance controls. 3. Temporary workarounds become permanent integration behavior. 4. Key insight: stability is sacrificed silently to regain short-term availability.
Why this is a migration-exclusive failure.
1. ECC landscapes evolved gradually with time to correct mistakes. 2. S4 HANA migrations compress risk into a short cut-over window. 3. Emergency fixes are applied when rollback is no longer possible. 4. The resulting instability persists long after go-live.
Ownership, integration-led, governance required.
This is not a technical failure, it is a governance failure. 1. Integration consultant identifies emergency fixes and undocumented changes. 2. Testing team assesses regression risk introduced by quick patches. 3. Basis team tracks direct production changes made during stabilization. 4. Data team monitors downstream effects of unstable behavior. 5. Leadership owns the decision to allow or reject emergency fixes.
How this is actually fixed, the right way by a role.
1. Integration team documents and rationalizes all emergency fixes post-go-live. 2. Testing team performs structured regression testing on stabilized interfaces. 3. Basis team enforces transport discipline immediately after cutover. 4. Data team validates long-term data consistency following emergency changes. 5. Leadership mandates cleanup and redesign of all temporary fixes.
What not to do, common wrong fixes.
1. Leaving emergency fixes undocumented because the system is now stable. 2. Building new logic on top of temporary workarounds. 3. Skipping regression testing to maintain momentum. 4. Treating stabilization as a permanent operating mode.
Follow-up 1. Why do emergency fixes cause problems months later?
Answer: emergency fixes are designed to solve a narrow symptom under pressure. They often bypass design assumptions and introduce hidden side effects. As volumes grow and usage expands, these side effects accumulate and destabilize the landscape.
Follow-up 2. Why is it hard to remove emergency fixes once applied?
Answer: once business processes rely on the workaround, removing it risks renewed disruption. Without documentation or testing coverage, teams fear touching the fix. This turns a temporary patch into permanent technical debt.
Follow-up 3. Curveball. Why is leadership accountability critical here?
Answer: because emergency fixes are business decisions under pressure, not just technical actions. Leadership must balance short-term continuity against long-term stability. Without explicit ownership, shortcuts become normalized.
Exclusive pro tip.
If an interface fix cannot survive full regression testing after go-live, it was never a fix, it was a gamble.
Category 7 wrap-up. When what was never tested finally breaks.
Testing and cutover failures prove that most post-go-live issues are not surprises, they are deferred risks. Interfaces fail not because they were poorly built, but because they were never exercised under real pressure, real volume, or real sequencing. S4 HANA migration simply accelerates the moment of truth.
Transition from visible failures to invisible ones.
After stabilization, projects expect calm. Instead, a new class of failures emerges. Issues that cannot be reproduced on demand, disappear after restarts, or occur only under specific conditions. These are the most dangerous problems because they resist traditional troubleshooting.
Category 8. Post-go-live ghost issues.
Ghost issues appear only under specific timing, load, or data combinations. Interfaces work perfectly most of the time, then fail without pattern or explanation. S4 HANA's parallelism, scale, and complexity make these failures more frequent and far harder to diagnose.
Scenarios covered in Category 8.
1. Interfaces fail only during month-end load ownership, not an integration-only fix. 2. Same interface works for some company codes, only ownership, integration-led data support. 3. Interfaces resume after restart without root cause ownership, not an integration-only fix.
Scenario 24. Interfaces fail only during month-end load.
After go-live stabilization, interfaces operate reliably for most of the month. However, during month-end close, failures suddenly appear. Messages time out, data loads stop midway, or downstream systems report missing records. Once month-end passes, the same interfaces return to normal behavior.
Scenario analysis and root cause.
This issue is misleading because it appears tied to business timing, not integration design. 1. Month-end introduces peak transaction volume and parallel processing. 2. Background jobs, reconciliations, and reporting run simultaneously. 3. Interfaces compete for shared resources and locks. 4. Key insight: the interface is correct, but the system is overloaded in specific windows.
Why this is a migration-exclusive failure.
1. ECC month-end loads were slower and more serialized. 2. S/4HANA accelerates execution and increases concurrency. 3. Migration preserves month-end processing patterns without redesign. 4. Failures appear only when peak load and parallelism combine.
Ownership, not an integration-only fix.
Resolving this issue requires system-wide coordination. 1. Integration consultant identifies interfaces sensitive to peak load windows. 2. Basis team analyzes system resource contention during month-end. 3. ABAP team reviews locking, update tasks, and commit behavior. 4. Finance team confirms critical month-end processing timelines. 5. Leadership prioritizes stability over speed during close.
How this is actually fixed. The right way by a role.
1. Integration team reschedules non-critical interfaces outside month-end peaks. 2. Basis team tunes resources and work process allocation for close periods. 3. ABAP team reduces lock duration and optimizes update logic. 4. Finance team aligns close activities with interface availability. 5. Leadership enforces month-end specific operating rules.
What not to do, common wrong fixes.
1. Restarting interfaces repeatedly during month-end. 2. Disabling validations to push data through. 3. Blaming HANA performance without load analysis. 4. Accepting month-end failures as unavoidable.
Follow-up 1. Why do these failures never occur mid-month?
Answer: mid-month processing runs at lower volume and concurrency. Month-end combines high transaction volume, parallel jobs, and reporting. This combination exposes resource contention that does not exist during normal operations.
Follow-up 2. Why don't system metrics always show obvious problems?
Answer: standard monitoring averages behavior over time. Short-lived spikes during month-end may not trigger alerts, yet they are enough to disrupt interfaces. End-to-end timing analysis is required to see the issue.
Follow-up 3. Curveball. Why is month-end instability considered a governance issue?
Answer: because month-end priorities are business decisions. Without clear rules on what can run during close, technical teams cannot guarantee stability. Governance defines acceptable trade-offs between speed and certainty.
Exclusive pro tip.
If an interface fails only at month-end, the problem is not randomness. It is ungoverned peak load.
Scenario 25. Same interface works for some company codes only.
After go-live, an interface appears stable for most of the organization, but fails consistently for specific company codes. Messages process successfully for some entities while others experience errors, missing data, or inconsistent results. Technical logs show no obvious differences between executions.
Scenario analysis and root cause.
This issue is often mistaken for random behavior or user error. 1. Company codes differ in configuration, data volume, and business rules. 2. Legacy interfaces assume uniform behavior across organizational units. 3. S/4HANA enforces stricter validations based on company code-specific settings. 4. Key insight: the interface is correct for some business contexts, not all.
Why this is a migration-exclusive failure.
1. ECC tolerated broader configuration variants with fewer runtime checks. 2. S/4HANA validates data more deeply at execution time. 3. Migration preserves historical configuration inconsistencies. 4. Failures surface only when stricter S/4HANA rules are applied.
Ownership, integration-led, data support.
Resolution requires understanding both integration flow and business configuration. 1. Integration consultant identifies conditional logic triggered by company code. 2. Data team compares master and transactional data across company codes. 3. FICO consultant reviews configuration differences affecting postings. 4. ABAP team traces validation logic executed only for specific entities. 5. Leadership decides whether to harmonize or explicitly support differences.
How this is actually fixed, the right way by a role.
1. Integration team validates interfaces against all company code variants. 2. Data team cleanses and aligns master data inconsistencies. 3. FICO team standardizes configuration where possible. 4. ABAP team adjusts logic to handle documented differences explicitly. 5. Leadership enforces consistency or controlled exceptions.
What not to do, common wrong fixes.
1. Adding company code-specific hacks without analysis. 2. Assuming failing company codes are edge cases. 3. Fixing data manually without addressing root causes. 4. Declaring partial success as acceptable.
Follow-up 1. Why do only certain company codes fail?
Answer: different company codes often have unique configurations, currencies, or regulatory rules. S/4HANA enforces these differences more strictly at runtime. Interfaces that assume uniform behavior break when these distinctions matter.
Follow-up 2. Why wasn't this caught during testing?
Answer: testing usually focuses on representative or high-volume company codes. Smaller or region-specific entities are often excluded. These entities surface hidden configuration and data issues only after go-live.
Follow-up 3. Curveball. Why is this considered a data issue, not just integration?
Answer: because integration logic executes correctly but fails based on input context. The true problem lies in inconsistent data and configuration across company codes. Integration simply exposes that inconsistency.
Exclusive pro tip.
If an interface works for some company codes and not others, compare configuration before code. The difference is almost always intentional but undocumented.
Scenario 26. Interfaces resume after restart without root cause.
After go-live, interfaces fail unpredictably and then resume working after a system restart or interface reprocessing. No configuration changes are made, no data is corrected, and no clear root cause is identified. The issue disappears temporarily, only to reappear days or weeks later.
Scenario analysis and root cause.
This issue is often dismissed because it resolves itself. 1. Restarts clear memory, locks, queues, and temporary states. 2. Underlying problems such as race conditions, resource leaks, or deadlocks remain. 3. S/4HANA parallelism increases the likelihood of hidden state issues. 4. Key insight: restarts hide symptoms but do not remove the cause.
Why this is a migration-exclusive failure.
1. ECC environments accumulated state more slowly and predictably. 2. S/4HANA executes more work in parallel and at higher throughput. 3. Migration preserves legacy logic that was never designed for this scale. 4. Issues appear only when modern execution patterns stress old assumptions.
Ownership, not an integration-only fix.
This class of issue requires deep cross-layer investigation. 1. Integration consultant correlates failures with timing, load, and restart events. 2. Basis team analyzes system resources, queues, and memory behavior. 3. ABAP team investigates locking, buffering, and transactional state handling. 4. Data team validates no partial or duplicate processing occurred. 5. Leadership resists closing incidents without root cause analysis.
How this is actually fixed, the right way by a role.
1. Integration team documents failure patterns instead of restart timing. 2. Basis team performs detailed resource and queue analysis. 3. ABAP team fixes state management, locking, or retry logic. 4. Data team reconciles affected periods for hidden corruption. 5. Leadership enforces root cause resolution before incident closure.
What not to do, common wrong fixes.
1. Closing incidents because a restart fixed the issue. 2. Scheduling regular restarts as a stability strategy. 3. Assuming the problem was environmental noise. 4. Ignoring recurrence patterns because failures are rare.
Follow-up 1. Why do restarts appear to fix the problem?
Answer: restarts clear temporary states such as locks, memory buffers, and queues. This resets the system to a clean state, allowing processing to continue. However, the underlying logic flaw or resource issue remains unchanged and will resurface under similar conditions.
Follow-up 2. Why are these issues so hard to diagnose?
Answer: because the failure state is transient and disappears after restart. Logs often lack clear errors, and reproduction is difficult. Without correlating timing, load, and execution paths, the root cause remains hidden.
Follow-up 3, curveball. Why is relying on restarts considered dangerous?
Answer: because it masks real defects and allows silent data corruption to persist. Over time, repeated restarts normalize instability and erode confidence in the system. Eventually, the issue escalates into a major outage.
Exclusive pro tip.
If an interface only works after a restart, the system is telling you exactly where to look, at hidden state and concurrency defects.
Category 8, wrap-up. When problems refuse to stay broken.
Post-go-live ghost issues expose the limits of traditional troubleshooting. These failures appear, disappear, and reappear without clear cause because they are rooted in timing, state, and complexity rather than defects. S/4HANA does not create these issues. It simply removes the buffers that once hid them.
Transition from technical failures to accountability failures.
At this stage, most technical issues have already revealed themselves. What remains are failures of ownership, decision-making, and governance. These are the most persistent problems because they cannot be solved with code, tuning, or retries.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP job interviews like SAP Master Data Governance MDG Consultant Jobs, SAP Business Technology Platform BTP Consultant Jobs, SAP Business Objects Data Services BODS Consultant Jobs, SAP Analytics Cloud SSC Consultant Jobs, SAP Cloud Platform Integration CPI Consultant Jobs, SAP S4 HANA Consultant Jobs, and SAP Functional Modules Interviews jobs like SAP MM Consultant Jobs, SAP FICO Consultant Jobs, SAP SD Consultant Jobs, SAP PP Consultant Jobs, SAP Ariba Consultant Jobs, SAP Extended Warehouse Management EWM Consultant Jobs, SAP Plant Maintenance PM Consultant Jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Category 9, ownership and governance failures.
Ownership failures are the root cause behind repeated integration breakdowns. When no one owns interfaces end-to-end, monitoring lies, issues bounce between teams, and migration decisions are never revisited. In S/4HANA programs, weak governance turns manageable issues into chronic instability.
Scenarios covered in Category 9.
1. No clear end-to-end interface ownership, leadership. 2. Interface monitoring is green but business is red ownership, not an integration-only fix. 3. Integration design never revisited after migration leadership.
Scenario 27. No clear end-to-end interface ownership.
After go-live, interface issues bounce between teams without resolution. Integration says the message was delivered. Basis confirms systems are up. ABAP finds no dumps and business reports failures continue. Each team owns a piece, but no one owns the outcome.
Scenario analysis and root cause.
This issue persists because responsibility is fragmented. 1. Interfaces span multiple systems, teams, and technologies. 2. Ownership is defined by component, not by business outcome. 3. Issues fall into gaps between organizational boundaries. 4. Key insight: when everyone owns a part, no one owns the result.
Why this is a migration-exclusive failure.
1. ECC landscapes evolved with stable, long-lived ownership structures. 2. S4 HANA migrations introduce new tools, teams, and responsibilities. 3. Old ownership models are reused without adjustment. 4. Gaps appear only when complexity and change accelerate.
Ownership, leadership.
This is a governance failure, not a technical one. 1. Project leadership defines and enforces end-to-end ownership. 2. Integration consultant provides technical visibility across the flow. 3. Business owners validate functional outcomes, not logs. 4. All technical teams support resolution within defined boundaries. 5. PMO/governance maintains accountability models.
How this is actually fixed. The right way by a role.
1. Leadership assigns a single accountable owner per interface. 2. Integration teams document end-to-end flow ownership clearly. 3. Business outcomes are tied to interface health metrics. 4. Escalation paths are defined and enforced. 5. Governance reviews ownership as systems evolve.
What not to do. Common wrong fixes.
1. Letting incidents bounce between teams. 2. Treating ownership as a documentation exercise only. 3. Assuming technical success equals business success. 4. Escalating without clear accountability.
Follow-up 1. Why does this problem persist even with strong teams?
Answer: because skill does not replace accountability. Even strong teams optimize for their own components. Without a single owner responsible for outcomes, issues stall in handoffs and debates rather than resolution.
Follow-up 2. Why isn't integration automatically the owner?
Answer: integration owns the transport, not the business result. Many failures originate outside the integration layer. Assigning ownership based on technology creates blind spots where problems are dismissed as someone else's responsibility.
Follow-up 3. Curveball. Why is ownership more important after go live?
Answer: because change does not stop after go live. Enhancements, fixes, and optimizations continue. Without ownership, the integration landscape degrades over time instead of improving.
Exclusive pro tip.
If no one can say this interface is mine end-to-end, then no one can guarantee it works for the business.
Scenario 28. Interface monitoring is green but business is red.
After go live, interface dashboards show healthy status across middleware and SAP monitoring tools. Messages are processed, queues are empty, and no errors are reported. Despite this, business users report missing postings, incorrect balances, or downstream systems that do not reflect reality.
Scenario analysis and root cause.
This issue exists because technical success is mistaken for business success. 1. Monitoring tools track message delivery, not business outcomes. 2. Interfaces complete successfully even when business semantics are wrong. 3. Failures occur downstream in finance, analytics, or operational usage. 4. Key insight: green monitoring reflects transport health, not business correctness.
Why this is a migration-exclusive failure.
1. ECC integrations relied on simpler business semantics. 2. S4 HANA introduces deeper validation and object behavior. 3. Migration preserves technical monitoring without upgrading business checks. 4. The gap between technical and business health widens post-migration.
Ownership, not an integration-only fix.
This issue spans IT monitoring and business validation. 1. Integration consultant identifies where technical monitoring stops. 2. Business owners define what success looks like operationally. 3. Data team reconciles expected versus actual outcomes. 4. ABAP/application teams trace failures beyond interface boundaries. 5. Leadership demands outcome-based monitoring.
How this is actually fixed. The right way by a role.
1. Integration team extends monitoring to include business checkpoints. 2. Business teams define reconciliation and validation rules. 3. Data teams implement post-processing verification. 4. Application teams expose business-level status indicators. 5. Leadership enforces business health as the primary KPI.
What not to do. Common wrong fixes.
1. Closing incidents because dashboards are green. 2. Adding more technical alerts without business context. 3. Assuming users are misinterpreting reports. 4. Treating business complaints as non-technical issues.
Follow-up 1. Why doesn't standard monitoring catch these issues?
Answer: standard monitoring focuses on message transmission and processing. It does not validate whether the message resulted in the intended business outcome. Without reconciliation or outcome checks, monitoring remains blind to semantic failures.
Follow-up 2. Why do teams trust green dashboards too much?
Answer: because green dashboards provide a sense of control and closure. They simplify complex systems into binary status indicators. Unfortunately, this abstraction hides deeper business failures that require cross-team investigation.
Follow-up 3. Curveball. Why is this dangerous for leadership?
Answer: because decisions are made based on reported system health. If monitoring shows green while business is failing, leadership is misled. This erodes trust and delays corrective action until impact becomes severe.
Exclusive pro tip.
If your monitoring cannot tell you whether the business succeeded, it is not monitoring, it is logging.
Scenario 29. Integration design never revisited after migration.
After go live, interfaces continue running exactly as they were designed during the migration phase. No one reassesses whether assumptions still hold, whether business usage has changed, or whether temporary decisions should be reversed. Over time, integration becomes increasingly misaligned with how the business actually operates.
Scenario analysis and root cause.
This issue emerges slowly and is often mistaken for natural system aging. 1. Migration-driven design decisions are optimized for go-live, not steady state. 2. Temporary workarounds and shortcuts are never formally retired. 3. Business processes evolve while integration logic remains frozen. 4. Key insight and integration that is never revisited will eventually become wrong.
Why this is a migration-exclusive failure.
1. ECC integrations matured gradually over many years. 2. S4 HANA migrations compress years of change into months. 3. Design decisions are locked under time pressure. 4. Post-go-live review is rarely planned or funded.
Ownership, leadership.
This failure exists because no one is accountable after go-live. 1. Project leadership owns post-migration design review commitments. 2. Integration consultant identifies legacy assumptions that no longer apply. 3. Business owners validate evolving process needs. 4. Architecture teams define target state integration patterns. 5. Governance bodies enforce periodic design reassessment.
How this is actually fixed. The right way by a role.
1. Leadership mandates a post-go-live integration design review. 2. Integration teams identify temporary migration compromises. 3. Architecture teams define steady-state patterns. 4. Business teams confirm real usage versus assumptions. 5. Governance tracks design debt as a first-class risk.
What not to do. Common wrong fixes.
1. Assuming working interfaces are correct interfaces. 2. Treating migration design as final architecture. 3. Postponing redesign indefinitely due to stability fears. 4. Letting integration degrade quietly over time.
Follow-up 1. Why do migration-era decisions age so badly?
Answer: migration decisions are made under extreme time pressure and uncertainty. They prioritize survival over optimization. Once business operations normalize, those compromises no longer align with real usage or long-term strategy.
Follow-up 2. Why don't teams revisit integration by default?
Answer: because success is measured by system uptime, not architectural fitness. Once interfaces run, they are deprioritized in favor of new features. Without explicit governance, redesign never becomes anyone's responsibility.
Follow-up 3. Curveball. Why is this more dangerous than a broken interface?
Answer: because broken interfaces trigger action immediately. Slowly decaying integration erodes data quality, trust, and agility over time. By the time the damage is visible, correction is far more expensive.
Exclusive pro tip.
If your integration design has not been reviewed since go live, you are no longer running a migration solution. You are running unmanaged technical debt.
Category 9 wrap-up. When integration fails without breaking.
Ownership and governance failures are the most dangerous because they do not look like failures. Interfaces run, monitoring is green, and systems stay online, yet business confidence erodes quietly. In ECC to S4 HANA migrations, weak ownership turns solvable technical issues into permanent organizational pain.
Transition, the scenarios no one plans for.
Even after covering every major migration failure pattern, there are still edge cases that repeatedly surface in real programs. These are not core migration blockers, but when they appear, they consume disproportionate time, create confusion, and trigger escalations late in the program.
Bonus scenarios, high-friction edge cases in real migrations.
The following bonus scenarios are not missing pillars, they are amplifiers. Each one overlays the categories you've already seen, making existing issues harder to diagnose, harder to own, and harder to resolve. They are included to complete the real-world picture without disturbing the core framework.
Bonus scenarios covered.
1. SAP notes or support package changes break stable interfaces. 2. CPI flow version drift across DEV, CAS, and prod. 3. Cloud connector configuration or resource limits cause intermittent failures. 4. External vendors or partners not fully S/4HANA ready. 5. Post-go-live security or compliance tightening breaks working integrations.
Bonus scenario 1. SAP notes or support package changes break stable interfaces.
After go-live stabilization, interfaces that have been running reliably for weeks or months suddenly begin failing after an SAP note implementation or support package upgrade. No integration logic was changed intentionally, yet message behavior, validations, or payload expectations shift unexpectedly.
Scenario analysis and root cause.
This issue is often dismissed as bad timing rather than structural risk. 1. SAP notes frequently adjust validation logic, field behavior, or API semantics. 2. Support packages may alter CDS views, authorization checks, or business object rules. 3. Interfaces depend on implicit behavior that was never formally contracted. 4. Key insight notes fix bugs, but they also change assumptions.
Why this happens more often in S/4HANA.
1. S/4HANA evolves faster than ECC through continuous innovation. 2. APIs, CDS views, and business validations are actively refined. 3. Migration-era interfaces rely on early release behavior. 4. Post-go-live system maturity exposes hidden coupling.
Ownership, not an integration-only fix.
This issue sits at the intersection of support, architecture, and governance. 1. Integration consultant identifies which interfaces rely on changed behavior. 2. ABAP team analyzes functional impact of notes and SPs. 3. Basis team controls transport and deployment timing. 4. Business owners validate post-change business outcomes. 5. Leadership governs change impact acceptance.
How this is actually fixed the right way.
1. Integration team assesses interface impact before applying notes or SPs. 2. ABAP team reviews SAP change logs for semantic impact. 3. Testing team executes focused regression on integration flows. 4. Business validates end-to-end outcomes after changes. 5. Leadership enforces controlled change windows post-go-live.
What not to do.
1. Applying notes directly in production under pressure. 2. Assuming SAP-delivered changes are always backward compatible. 3. Skipping integration regression testing for small fixes. 4. Treating recurring breakage as unavoidable.
Follow-up 1. Why do SAP notes impact integration unexpectedly?
Answer: SAP notes often correct edge cases or enforce stricter validation. While technically correct, these changes can break interfaces that relied on lenient or undocumented behavior. The impact appears sudden because the dependency was never explicit.
Follow-up 2. Why is this harder to manage post-go-live?
Answer: because urgency shifts from project delivery to business continuity. Changes are applied faster, often with limited testing. This increases the risk of unintended integration side effects.
Follow-up 3. Curveball. Why is this a governance issue, not a SAP issue?
Answer: because SAP provides change, not impact analysis for your landscape. Governance determines how and when changes are applied. Without governance, technical correctness still results in business disruption.
Exclusive pro tip.
In S/4HANA, stability does not mean immutability. Every SAP change is an architectural event for integration.
Bonus scenario 2. CPI flow version drift across DEV, CAS, and prod.
After go-live, an interface behaves correctly in one environment but fails or behaves differently in another. Investigation reveals that CPI flows were patched, redeployed, or modified inconsistently across DEV, CAS, and prod. No single environment reflects the intended design anymore.
Scenario analysis and root cause.
This issue is often invisible until an incident occurs. 1. CPI allows direct changes without strict transport enforcement. 2. Emergency fixes or tests are applied in one tenant only. 3. Design time and runtime artifacts drift apart. 4. Key insight, environment inconsistency becomes the failure itself.
Why this happens more often in S/4HANA.
1. CPI becomes central during S/4HANA integration redesign. 2. Multiple teams modify flows under time pressure. 3. Transport discipline is weaker than on-prem SAP. 4. Post-go-live changes accumulate silently.
Ownership, integration-led, governance required.
This issue is not technical, it is process-related. 1. Integration consultant detects behavioral differences across tenants. 2. CPI administrators control deployment and artifact promotion. 3. Testing team validates consistency across environments. 4. Basis/platform team manages tenant access and permissions. 5. Leadership enforces CPI change governance.
How this is actually fixed the right way.
1. Integration team establishes strict CPI transport and promotion rules. 2. All changes are versioned and traceable. 3. Testing validates flow behavior in all environments. 4. Emergency changes are retrofitted into DEV immediately. 5. Leadership treats CPI like core SAP, not a sandbox.
What not to do.
1. Making direct fixes in prod only. 2. Assuming DEV reflects production reality. 3. Letting multiple versions coexist without clarity. 4. Relying on memory instead of version control.
Follow-up 1. Why is CPI especially prone to version drift?
Answer: because CPI enables fast, UI-driven changes and does not enforce SAP-style transports by default. Without governance, teams optimize for speed and unintentionally fragment environments.
Follow-up 2. Why does this surface late?
Answer: as long as each environment is used independently, drift remains invisible. Problems emerge only when behavior is compared or when production incidents force cross-environment analysis.
Follow-up 3. Curveball. Why is this a leadership concern?
Answer: because uncontrolled changes undermine trust in the platform. When environments diverge, root cause analysis becomes unreliable. Leadership must enforce discipline to maintain system credibility.
Exclusive pro tip.
If CPI does not have transport discipline, it will eventually become your most unstable system.
Bonus scenario 3. Cloud connector configuration or resource limits cause intermittent failures.
After go-live, on-premise integrations routed through SAP Cloud Connector begin failing intermittently. Sometimes interfaces run flawlessly for days, then suddenly time out or disconnect without configuration changes. A restart or short wait often resolves the issue, making it difficult to diagnose.
Scenario analysis and root cause.
This issue is often mistaken for network instability. 1. Cloud connector enforces connection, memory, and thread limits. 2. Peak loads exhaust available resources silently. 3. Location IDs and resource mappings are tightly scoped. 4. Key insight: the connector becomes the bottleneck, not SAP or CPI.
Why this happens more often in S/4HANA.
1. S/4HANA increases call frequency and parallelism. 2. More APIs replace fewer batch interfaces. 3. Legacy cloud connector sizing assumptions no longer hold. 4. Migration increases load without revisiting connector design.
Ownership, basis-led, integration support.
This issue spans infrastructure and integration design. 1. Integration consultant identifies traffic patterns through the connector. 2. Basis team monitors resource usage and sizing. 3. Network team validates connectivity and latency. 4. CPI team correlates failures with execution peaks. 5. Leadership approves capacity and scaling decisions.
How this is actually fixed the right way.
1. Basis team reviews and increases cloud connector capacity. 2. Integration team optimizes call patterns and batching. 3. CPI throttling is aligned with on-prem limits. 4. Monitoring is added at connector level, not just CPI. 5. Leadership treats Cloud Connector as critical infrastructure.
What not to do.
1. Restarting Cloud Connector as a permanent solution. 2. Assuming network teams alone can fix the issue. 3. Ignoring connector metrics during troubleshooting. 4. Scaling CPI without checking on-prem limits.
Follow-up 1. Why do restarts temporarily fix Cloud Connector issues?
Answer: restarts clear exhausted threads, memory, and stale connections. This restores capacity briefly, but the underlying load pattern remains unchanged. Without redesign or resizing, the issue will recur.
Follow-up 2. Why is this hard to reproduce?
Answer: failures occur only when concurrency and volume cross specific thresholds. These thresholds are rarely hit in testing, but are common in production under real business load.
Follow-up 3. Curveball. Why is Cloud Connector often overlooked?
Answer: because it is perceived as plumbing. Teams focus on CPI and S4 logic, forgetting that all traffic funnels through a finite gateway. When it saturates, everything upstream looks broken.
Exclusive pro tip.
If CPI is fast and S4 is healthy but calls still fail, look at the Cloud Connector. It is often the silent choke point.
Bonus scenario 4. External vendors or partners are not fully S/4HANA ready.
After migration, integrations with banks, tax vendors, logistics providers, or SaaS platforms begin failing or producing inconsistent results. From the SAP side, interfaces are modernized and compliant. However, external partners still operate on ECC-era assumptions, formats, or validation logic, creating friction that surfaces late.
Scenario analysis and root cause.
This issue is often misinterpreted as an internal integration defect. 1. External vendors certify ECC compatibility but lag in S4 semantic readiness. 2. Partners expect legacy field usage, timing, or batching behavior. 3. S4HANA payloads are technically correct but semantically unfamiliar to partners. 4. Key insight: integration correctness is constrained by the least modern participant.
Why this happens more often in S/4HANA.
1. S4HANA adoption progresses faster than partner upgrade cycles. 2. Vendors prioritize core SAP certification over edge case integration. 3. Migration timelines rarely align across organizations. 4. Gaps surface only when real business scenarios are executed.
Ownership, integration-led, vendor and business involvement required.
This is a coordination failure across organizational boundaries. 1. Integration consultant identifies semantic mismatches in payloads and timing. 2. Business owners validate vendor readiness and contractual expectations. 3. External vendors confirm supported formats and behaviors. 4. ABAP/CPI teams implement controlled adaptation where unavoidable. 5. Leadership escalates and governs partner alignment.
How this is actually fixed the right way.
1. Integration team validates vendor interfaces against real S4 scenarios. 2. Vendors update or certify payload handling explicitly for S4HANA. 3. Temporary adapters are documented and time-bound. 4. Business renegotiates SLAs where readiness gaps exist. 5. Leadership enforces external dependency risk tracking.
What not to do.
1. Forcing S4 to mimic ECC behavior permanently. 2. Assuming vendor certification equals integration readiness. 3. Hard-coding partner-specific quirks without governance. 4. Hiding vendor gaps through silent workarounds.
Follow-up 1. Why do vendors claim readiness but still fail?
Answer: most vendor readiness focuses on core APIs or happy paths. Real-world scenarios, edge cases, and timing dependencies are often untested. Integration exposes these gaps immediately.
Follow-up 2. Why is this usually discovered late?
Answer: because vendor testing is often limited to basic certification scenarios. Full business flows are executed only after go-live, when rollback options are limited.
Follow-up 3. Curveball. Why is this a leadership issue?
Answer: because vendors respond to contractual pressure, not technical arguments. Without leadership escalation and governance, integration teams are forced to absorb external shortcomings indefinitely.
Exclusive pro tip.
If an external partner is not contractually S4HANA ready, integration will carry the cost, unless leadership intervenes.
Bonus scenario 5. Post-go-live security or compliance tightening breaks working integrations.
After go-live, security or compliance teams introduce stricter controls such as tighter authorizations, reduced service user privileges, new audit policies, or enhanced encryption requirements. Interfaces that worked reliably before these changes suddenly begin failing, even though no integration logic was modified.
Scenario analysis and root cause.
This issue arises when security improvements are applied without integration impact analysis. 1. Post-go-live audits often identify excessive privileges granted during migration. 2. Security teams tighten roles, authorizations, or network rules to meet compliance. 3. Integration service users lose access required for business execution. 4. Key insight: security hardening exposes undocumented integration dependencies.
Why this happens more often in S/4HANA.
1. Migration phases prioritize continuity over least privilege design. 2. Temporary authorizations granted during cutover are never revisited. 3. S/4HANA introduces stricter compliance expectations. 4. Security review cycles often lag behind go-live.
Ownership, security-led, integration, and business support required.
This issue must be resolved without compromising compliance. 1. Security team defines compliant authorization and access models. 2. Integration consultant maps required permissions to business flows. 3. ABAP team traces authorization checks triggered by interfaces. 4. Business owners validate acceptable risk and access needs. 5. Leadership balances compliance with operational continuity.
How this is actually fixed the right way.
1. Integration team documents exact authorization requirements per interface. 2. Security team redesigns roles using least privilege principles. 3. ABAP team supports authorization trace analysis. 4. Business validates that compliant access still enables operations. 5. Leadership approves controlled exceptions where justified.
What not to do.
1. Reintroducing broad authorizations to restore functionality. 2. Bypassing security controls for integration users. 3. Treating compliance failures as technical noise. 4. Allowing undocumented access creep to return.
Follow-up 1. Why do integrations break after security tightening?
Answer: because many interfaces rely on implicit or undocumented permissions granted during migration. When security teams remove these privileges, the dependency becomes visible. The interface was never truly compliant to begin with.
Follow-up 2. Why is this often blamed on security teams?
Answer: because the breakage coincides with security actions. In reality, security is correcting an existing risk. The root problem is missing documentation and governance of integration access needs.
Follow-up 3. Curveball. Why is leadership involvement essential here?
Answer: because compliance and business continuity are both executive responsibilities. Only leadership can approve risk trade-offs and ensure that integration remains both secure and functional.
Exclusive pro tip.
If tightening security breaks an interface, the interface was never compliant. It was only tolerated.
Final wrap-up. Why ECC to S/4HANA integration fails, and how to prevent it.
ECC to S/4HANA migration does not fail because of technology. It fails because assumptions are carried forward without challenge. Across modernization, data semantics, timing, security testing, post-go-live stability, and governance, the same pattern repeats. Interfaces work technically but break behaviorally. An SAP integration consultant's real value is not in moving messages. It is in protecting business meaning across change. If you recognize these scenarios, you are not behind, you are experienced. These failures are not signs of poor design. They are signs of complex transformation. The difference between unstable migrations and resilient ones is not heroics at go-live, but architectural thinking, ownership clarity, and continuous validation after go-live.
The core lesson.
Successful S/4HANA integration is not achieved by making interfaces green. It is achieved by making the business correct, repeatable, and explainable under real load, real timing, and real governance. Every scenario in this video exists to remind you of that responsibility. If this video helped you anticipate problems instead of reacting to them, it has done its job. Share it with your team, revisit it before go live, and use it as a checklist when integration issues feel random. In S/4HANA programs, they never are.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP job interviews like SAP Master Data Governance (MDG) Consultant Jobs, SAP Business Technology Platform (BTP) Consultant Jobs, SAP Business Objects Data Services (BODS) Consultant Jobs, SAP Analytics Cloud (SAC) Consultant Jobs, SAP Cloud Platform Integration (CPI) Consultant Jobs, SAP S/4HANA Consultant Jobs, and SAP Functional Modules Interviews jobs like SAP MM Consultant Jobs, SAP FICO Consultant Jobs, SAP SD Consultant Jobs, SAP PP Consultant Jobs, SAP Ariba Consultant Jobs, SAP Extended Warehouse Management (EWM) Consultant Jobs, SAP Plant Maintenance PM Consultant Jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.